probably the wrong bin. That's the wrong bin too. Oh, that's a copyright song. No! Bonk. The bin that has all of my weird displays in it. A little piece of like electronics foam, I think, that I kept them on. Where is that bin? Where did that go? I don't actually know. It's probably buried under eons of garbage that I've got sitting in this corner that I haven't cleaned up yet. Good God, this corner is a mess. Just like looking at it right now is just filling me with a sense of unaccomplishment. It's draining all of my motivation. Just visually draining all of my motivation. Yeah, smaller gets real finicky and annoying, and it's better to just save yourself the time of having headaches. But I think in some projects I need to have gone with smaller sized hardware just to make things fit better. Like this project, I could have used smaller surface mount stuff, and I may have to in order to get it to all fit inside of the Elite core. Here. So weird, just go metric. What's your problem? But yeah, some of the units on this thing worked out a little bit better in English. We didn't I'm dying. We didn't actually change our units to English for this. We kept it metric, but we had to do like 1.1 and like 2.5, probably 2.54. Bunk bed breadboards? That sounds crazy. Oh, you're just making a joke. I thought you had a dual layer breadboard. That'd be a hell of a project that would need that much space. These things do snap together. Yeah, happy Friday. Fridays seem to mean something to everybody else. I don't think I'm gonna be doing gaming tomorrow. I think I'm gonna take it easy. I wanted to do long drive. Maybe we'll find another day to do that. But on Sunday, I'm gonna be on Cosmo Quest X. They're having a hangout-a-thon. And so they wanted to get me for like an hour. I think it would be pretty cool. I was joking at first. Wait a minute. Hold on a minute. That's not a bad idea. I could 3D print something for that. Months later, yeah, I abandoned that project. It would be cool, but I still have my BMW flashlight, don't I? And it's still sitting on this fucking desk. This is for like, this is my former car's. It doesn't work anymore. It's a little like capacitor. Oh boy. Okay, so those are all the board files. That's for the order. And then we've got, holy shit, what are these files? Yikes. What are you going to allow me to import? What are the B1 through whatever? Rev1 lav board SCH. Let's see if that works and if I can view it. I don't really, what do I do for a living? I do consulting. There we go. I know people want to know because like, how can I end up doing this for a living? And it's a long story, and I don't want to go into it. It's I'm in a predicament.
We're getting very close to the end.
No talking. Metro's like, every time Metronomic has been in the chat before, and he's been like, every time I talk on stream, I can't help but think about when you tell me not to talk, and I'm like, no, don't, no, I'm just joking around.
This next track is one I wanted to get to.
But you should also stop talking. No, I am just joking around on them. Why does it? Fusion, can you please? The upload is so dumb sometimes.
We've done one other. It was like totally unannounced and happened by accident. I was playing back to back with a friend before quarantine, and it turned into a sunrise thing, and it was a lot of fun. But that was like when I had like 3.
No talking. All right, what's happening here, Eagle? What are you doing? Fusion and/or Eagle. So I ended up getting those the smaller laser tubes. I'll transplant the laser guts into the smaller tube, and then it'll all be silver on the burning end, but it'll be a lot more stable and sort of well constructed and permanent. Even though I'll be replacing the laser head eventually. Hello? 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 What the fuck is going on with this thing? Oh, look, it's gone. That's cool, I guess. Why is it stuck? What are you doing? Alright. Well, I tried to upload the schematic file, and I have absolutely no idea why it's not loading. That would help me rebuild the board. Hey, Mystery, how you doing? I mean, I could just open it up. Data in the folder's been updated, okay? Okay. Alright. Failed to download file. Requested source not found. I literally dragged and dropped it in. I don't know what you're thinking here. Okay. Okay. Alright. So we can't use that. Alright. Let's try. This is gonna be a total mess, but oh, not Altium. I need like the where's that basic one? These are like, yeah, just sign in for an account to blah blah blah. It's like, shut the fuck up. No. Like, somebody decided that they would be able to get and sell your personal data off of PCB viewing files. Like, I just, there's a basic one. Online Gerber reviewer. Yeah, I don't want JLPCB to have my information. Online Gerber. flashy.
Desert Hearts.
I just forget the URL. That's all it is. If I could remember the URL for that Gerber viewer, it used to be the one that came up on the search because nobody was looking for a Gerber viewer to sell people's information around the internet, which is like, God, is that depressing to have people come in and Google AdSense the shit out of your favorite website. Hey Pyro, what's up? Yeah, I would hope that they at least, like, because I thought there was like one ad on the page and it wasn't one of those non-intrusive banners. I would hope that that is enough to keep their website going. I think maybe they updated it. Or if I just try like PCB viewer online. I don't know anything about web coding like that. I don't think I would be able to. DuckDuckGo is a nice interface. That was a nice search. All right, well, we might as well get started because everybody seems to be trying to tell me websites to go to, but that's not really the point of what I'm searching. I was trying to find the tool that I love because it's so basic and hard to use and stupid, and it just shows you it shows you the board layout, which, you know, give it or take it. I guess it would be easier to see the board layout. Oh, shit. I opened the wrong thing. Go away. No, no, no. We don't need you. Or you. Start soon. There we go. All right. Yeah, I'm a little slow today. I'm tired. I didn't get much sleep. But it was an old website that had a very basic, I think it was a German website that had a very basic online Gerber viewer. So you could, when you generate the files to order a PCB, it helps to put it into something independent of the software that you're using to see what you're sending to the company. Now, the company that I send PCB files to, Seed Studio, they have their own Gerber viewer. And so I guess that website is useless now, which is sad because that was my happy place. That website is associated with a lot of positive emotions, I should say, because it's one of those things where you're done your PCB design, you've finished, you're free, and all you need to do is look at it one more time on this crappy little website that assigned all these terrible colors to the different layers that you're sending the publishing company, but printing company, I guess. I liked it a lot, and I can't find it now. And it's possible that it was mothballed or whatever, but my internet history, I don't know about that. I'm not gonna search my fucking internet history online, guys. Jesus Christ. What do you guys think this is? Man, you guys are like, maybe if you give me your address, you'll be able to find the website. Father, what's your social security number? Anyway, what are we doing today? Well, I need to build this. I need to build this because I need to modify this. I need to modify this. This is the circuit that powers the microphone that you're listening to right now. My smooth, buttery, dulcet tones are coming through to you through this circuit right here. And this circuit right here is a little bit of a mystery to me. I sort of just built it, put it together, and it works. And then I tuned around it with the EQ. So I tuned around those settings with this in order to give you what sounds good. This is not based on math. This is not scientific. This is me clicking on the screen and moving these things up and down until I sound good. So whatever I come up with to perform this function on this circuit, it may not do the same thing. It may not do it exactly the same way, but it will hopefully give me good sound on the other end of the mic. So my voice, all of the properties of my voice that you guys have gotten used to may change. It may change. But hopefully the real purpose of this, the whole purpose of doing this is to free myself from these tools, because these don't save your settings. And it's not like I have to put them in there every day, but I mean, if I click on the wrong button on this thing, no more settings. Away it goes. And I can't enter like numbers into this program in order to get it to go to the right values. I don't think. Maybe I can. Yeah, it looks like I can. So I could potentially like painstakingly reprogram all of the EQ stuff. But yeah, what I want to do is I want to build that into the mic. I want that to be automatic. I'll probably be plugging into channel 2 if we can get this done today. So yeah, we've got to start up our audio test bed. Let's get started with that. I'm gonna have to dig around and find parts and stuff too. The question is, I mean, I've already got the circuit sitting right here, right? This is the circuit. I've built it. I've already made it. I could go for building this up because then I'll have the availability of a second microphone. Although if we do succeed in this project, I won't need this anymore. That's kind of a weird thing. I don't know. I think maybe we're better off trying to build this thing independently. So the question is, what through-hole op amps do I have? Do I have something that's going to properly perform this task of audio filtration? It's kind of important selecting the op amps for this one because we're talking about a microphone circuit and we're talking about voice frequencies, and we have frequencies going through these things and they need to be like 10 volts stable and all that stuff. So let's see. Unity gain buffer, decrease signal noise ratio, make a little noisier. Selecting op amps, I think, was an important thing in here. Yeah, my prototype preamp uses OPA 2134. Gets voltage of a little over 10. 2134. I think he had like a list of ones that he likes to use. Make a list. Write stuff down. You need to eliminate all of the stupid stuff too. And if you're working with something like a perforated prototyping board, start over. Start over. Break it all down and build it up again. It's like a factory game, right? When things get a little bit too spaghetti, take all those lessons, wipe the floor, and just start over. Okay, so. Common variant, bobbity-ba, OPA, bobbity-bobbity-ba. Sound pressure levels, not really what we're looking at. Where does he talk about? Where does he talk about? What is this mod? Oh, that's for something else. That's for a different type of mic. If you're repairing hardware that already exists, what do? I would say make a list and check all the dumb stuff. And because like I've had like with a subwoofer project, when I was repairing my friend's subwoofer for me, because he just gave it to me, I looked at a lot of different stuff, and I was reading a lot of forums, and I was getting very, very into what I was doing, all the way down to the level of checking the ohms between different devices on the board itself, until I got no reading from one of my probes. And I was like, what is that? And then it turns out that a trace had broken right at the edge of the solder of that trace, because there's a lot of vibration in a subwoofer. So you have like a surface mount chip, and then you have the edge of the solder, and then the trace broke right at the edge of the solder. It was madness. Works now. I just put a piece of wire on it, made a big old solder bridge out of it. Yeah, but you can find that. It's not impossible. But you have to go down to a very low level. And the only reason you go down to that low level is that you have a list of other things that you've checked that you've exhausted. And so it's like, all right, it's time to do this, because I've ruled out all of the other possibilities. So like I said, make a list, make a list, make a list, make a list. Even the dumb stuff is plugged in. Did you plug it in? Did your probe slip? Probiscus? Check the wires, check the ohms. Go through the schematic. Line by line, as in, you know, line connecting thing to line connecting thing. Unfortunately, with electronics, it is necessary to be extraordinarily thorough. Okay, anyway. 2134, what op amps is he saying to use? I did not do my homework here. He's going to say nothing but, yeah, 39 times the word amp shows up, so. Maybe he'll mention the OPAs again. OPA, OPA! Dear God, he says op amp a lot. No, he doesn't really say it, does he? So here he uses the 2134. I know there's a couple op amps that he prefers. Let's see what I got. Let's see if I've got the right thing. Let's see if I've got the right thing. LM324. Oh, that's not promising. 2007s. What's the one that Shortlurker sent in? Shortlurker sent me a couple of these. What did he send? Maybe he sent me the right op amp. I don't think so, but he might have. Barring that, I can pop open the actual mic pack that I'm using right now. That one uses surface mount chips, but we can just put them on adapters. So that might be what we end up doing, is just putting surface mount parts on adapters. Dear God, this thing is like sealed. Okay, let's. What are you guys? Let me just make that list. Yeah, I'll cut and paste that over here. All right, I just have that in a browser now. Thank you, Fat. What do we got here? Oh, what do we got here? Oh, yeah. Wait a minute, I have an idea for this. Hold on, wait. Let's go here. Let me get chat. There's chat's on top of everything. Jeez, you guys should be below everything. There we go. Chat's there. Let's go here. Let's add chat back in, except there we go. A little continuity there. Perfect. Any 555. Hey, look at that. Wait a minute. No, that's just a 555. Any 5532 is the op amp. These are just 555. That's right. These were jokingly sent to me. What am I going to do with these things? I'll just put them in here. I'm never going to do the 555. I'm not going to do anything with the 555 ever. TL072. I only have LM324s because chat didn't buy me a lot of through-hole parts. They bought me some bare essentials. So buying parts. Okay, yeah, that's where he talks about this stuff. Cool. Thank you for the reference. Yeah, it's like, I don't know. People make fun of the project where you blink an LED using an Arduino, but like, there's more to it than that. You know, it's about learning how to use the Arduino more than it is about making an Arduino do one thing. And it's about enabling you to do your project with a lot of headroom. You blink an LED with a 555, that's it. Like, that's all you're able to do with a 555. You do timing pulses. Like, that's all it does. Whereas if you get the microcontroller and you get the microcontroller doing what you want it to do, then you can complicate it, you know? What do you have a cowboy hat in Chatterino? What is that? Oh, Frankerface Z supporter. Cool. Link is the hello world of Arduino. It is. That literally is. That's what it is. All right, let's get surface mount parts out, because that's where all these parts exist. So I'm gonna have to rifle through some of this stuff. I think it's in the unlabeled bins. I think that's where those are. But I'm gonna get out a whole stack of these parts, and we're gonna have to go from there. Been a little while since we've done anything in surface mount on stream. Kind of nice to get back to it. I'm a lot worse off than I thought I was this morning. I don't know what it is. I think I just slept really badly. I think I just got real bad sleep. Hold on, there's more bins. Ugh. There you go. Okay. So let's find us some op amps somewhere around here. Opa! Well, any 5532... Restart to install the latest update. Hey, how about you don't pop up Windows? Windows. Pick a time. Let's go at 4 a.m. 2:12 a.m. tomorrow. Yeah, let's do that. You know what? You picked a good time, Windows. So if hopefully we're not streaming until 2:12 a.m. Yeah, he has a lot of sections, man. There's a lot of stuff on that webpage. I hope Elliot stays around for a long time. It looks like I found the bin. I found the right bin that's containing all the parts, and I have been negligent in my labeling duties as of late. This bin was mostly blank. I filled it with those SparkFun parts. Somebody sent me a miscellaneous parts like prescription pill bottle. Yeah, it was cool though. I really appreciate that because there were a lot of cool things in that. I mean, it all stank of spark fun, though. You know, it was all very spark funny kind of stuff, but it had a lot of interesting stuff in it, which is sort of what we're all about here. All right, let's take a look at what's in here. Oh dear God, hey, there's just like a missing one. Okay. All right, finding parts. All right, let's see here. So, what do we got? How am I already out of desk space, you know? What's that all about? The 100K trim pots I do have. I do have those right here, so. Yeah, these containers have been a pretty good solution for storing and keeping organized. LT1494. We're looking for an NE5532, an MC4458, or a TL072. OPA, MC4558. There it is. That's one of them. 6021. I don't know about that one. Motor IC, and then these are all miscellaneous. Luckily, we don't need coils in this design. Coils are annoying. Nobody uses coils. You only use coils when you're forced to by a power supply. Man, I got a lot of those switches now. What are you? Well, either way, we found the op amp, the MC4458. If we really feel like it, we could probably also try the, I actually don't know. OPA 2337 or the LT1494. I think these were equivalents, but this one is the star of the show, I suppose. So let's get this thing out, and then let's put it on a board that will allow us to put it onto the perforated prototyping board. So what I need to do is I need to get these little circuits. You can buy them on like eBay. You can get these little circuit boards that will break out these parts. Wait, do I already have one that's broken out? Hold on, wait a minute. Hold on, back up. Stop the record. Rip. The little record scratch there. Let's see. I might already have one that's on a board. It might actually already be over here. I have to like selectively stack this stuff. Perf boarding a circuit is very involved. And one thing I gotta be really careful of is not to let any of these bins ever fall. If they fall to the ground, they all pop open and it jettisons the contents everywhere. It is obnoxious. All right, let's see if we've got, I may already have one of these op amps attached to a thing. So we need to look for that. Sorry, I'm like cleaning up at the same time because I need space to work and I don't seem to have it today. All right, let's see here. Yoink. That actually looks like an overlay over there. Okay, we are looking for, and I should probably use tweezers for this. We are looking for an op amp. These are not op amps. These are some other breakout board, right? Nate, Lift 151. Hey man, thank you for the 4 months. I appreciate that. Nice of you. That's nice of you. You're a pretty okay guy. All right. There's nothing on this one. Why do I keep this around? I'm throwing that out. Garbage. The hell was that? This is something somebody sent me, I think. Whatever the hell this thing is, the Spark Fun board. We're not using it, that's for sure. Anything else? I don't know what these are. I forget why I bought these. What is that part? Huh, I forget what these are. Let's see what the ins and outs are called. RH, RW, and RL. HWL, Inc, VD, CS, chip select. And it's something digital. The hell is this thing? Yeah, that's what it is. You're right. They're digital pots. Okay. There you go. All right, moving on. I'm looking for an op amp that I may have put on a board in order to run a circuit. What in the ever-loving fuck is this thing? Wait a minute. Why did I keep it? What is the purpose of this? Why is this here? What is this? Hey, what is this? Okay. I'm throwing this thing out. Oh, it's gone. Whatever the fuck that thing was. These are the ones at the bottom here. These are old LED control circuits that I built for my friend's fish tank that he never used. Never used them. Yeah, I don't think I have the wherewithal to be trolling myself from the past. Groovy woke up at 1. Holy shit. That's alright. The alternative is ending up like me, which is not really sleeping all that much and feeling like crap for some reason. You know, the reason being not sleeping. There's some, these are all pretty much just voltage regulators and some spillover from some other parts of the bins. I'm not incredibly organized, but I'm sort of borderline organized. So here's where we'll probably find it if it exists, which I think it does, because I mean we did a lot of breadboarding for this thing, and I think I put most of those op amps on their own boards. But I didn't label anything because I can barely see what's going on here. We're gonna have to get closer. We gotta prepare for an earthquake. Bonk. All right. Hode! Thank you for following. Ah! I get the shadows out of the way. Hold on. Everything is so shaky when we zoom in. Four, 5, 5, 8. Hey, there he is. There he is. It's Cool Cat. Ah, it's so shaky. 4, 5, 5, 8. I found it immediately. All right, cool. There we go. Here, let me put this back so you guys don't get seasick. Well, I'll put you back to here. All right, so we got our first amp. That's one part. Is this bending? Oh my god. What the f— look at this. There's a bend in my perf boards. They're bent. How the fuck? must have stacked something on top of it. I don't know. Alrighty. Man, this thing's getting dirty. I gotta clean this thing. Alright, so there's our op amp. This is the star of the show. Now this is a dual op amp. So there are 2 op amps in there, which means we've got all of the circuity things for this circuit. That's both the op amps. So the next thing that I need to find is a BC549. BC549. I know I went with a surface mount part when I actually did the what do you call it? When I built the circuit on the circuit board, it would be much easier if I could not use a surface mount transistor. BC549. Come on, baby. No. FETs, NPN, 40 volt, 0.2 amp. Well, let's take a look at this part because we need to find an equivalent. Because I don't think I have the through-hole version of that, and I don't know where I don't know what I used in the original circuit too. That's the other thing that we need to reference. So we're looking at BC549. BC549, 547, 548, components 101. Okay, so this is a very basic component, so there's probably a shit ton of equivalent parts. General purpose NPN, current gain 420 to 800, continuous current IC, 30 volts, emitter base 5, frequencies at 100 megahertz. So the ones that I have are all three. Well, wait, which one is this one? Is this NPN? Yeah, NPN. So 2N3904 is another jelly bean part. This one, 40 volts DC. 60 volt. So emitter base 5. VB emitter base 6. We could try it. Looks like it won't blow up, right? But like, what are the what's the frequency thing? Because that's we're talking in frequencies. So transition frequency is 100 megahertz. Let's see if we can find that on this page. It's not even there. Okay. All right. So we'll try it. We'll try it 2N3904. Push comes to shove, I can find whatever surface mount part I used in the actual mic pack and swap it in. But this is all about filtering my voice from phantom power, or vice versa, phantom power from my voice, or something of that nature. So yeah, okay. So 2N3904, we got 2 of those. Should probably verify that these are the right ones on the microscope, but actually read the part number. Make sure it ended up in the right bin. Now the Zener diode, I know we're gonna have to solder something for that. All right, that was our next big hurdle, was getting those 2. That was our next big hurdle. What else do we have in our bill of materials? A bunch of capacitors. 100 NF. I don't know where the hell I'm gonna get that. 100 micro. I'm not concerned about the resistors, by the way. I've got tons of resistors in a bin. I know that I have the right resistors. The capacitors are another animal entirely. I don't know what capacitors I have where. Well, I might as well just look for, let's get the big capacitor bin over here. That thing's been haunting my shop for some time. I gotta find it. Push comes to shove, we use the surface mount capacitors. And in that event, I guess I can make a little adapter board. A capacadapter, a cadapter board. Where is the big thing of capacitors? Where could it have gone? Tune in next time for, all right, let me see here. Those are D subs. I'm looking through these little bins that I have sort of behind things. Man, you know how cool it would be to have a shop where I could actually get to stuff? You know, I could actually like store things and then get to things that I need in order to perform all the tasks that I do around here. Probably need to reorganize this whole room. That'll happen at some point. That'll happen at some point. Just a full room reorganization. I don't know if they're here. Maybe they're up here. I don't think they would have ended up here, though. Oh, they are. They're right here. Capdapter. A capdapter. A cabadabur. Herpaterpaterp. Okay, let's see here. So I'm gonna need a couple capacitors from this thing. I'm gonna need 100U, 10U. Oh, that's it. I just need 100 microfarads and 10 microfarads. And they've got to be, what are the voltages on these things? Maybe I do need to open that buying guide. I know the other ones are like 50 volts. Blah, blah, blah. He's got a whole article on this. I think we lost Fadanon to the pages of Elliott Sound. Blah, blah, blah. Okay. Electrolytic. 35 or 63. Those are weird numbers. Okay. 30 to 60 volts. I guess. You're ordering op amps. All right, go over to here. Look at all these capacitors. Why is the camera so shaky today? Stop it. Oh my God. Every micro movement is causing, I need to 3D print something for the top of this microphone arm, because all that shakiness is caused by loose hardware. And unfortunately, I can't do anything to fully stabilize that. God damn, is it shaky. Okay. Okay, I'm gonna try to stay still so that you guys get good visuals here. Dear God. It's like, look. A soft tap is causing all that. I need to mount the microscope to like the wall or something. So 30 to 60 volts, and we need 100, what do we need, 100 microfarad? We need a couple of them, don't we? Hold on, BC549, 239, there's the circuit. Yeah, 100 microfarads. So we need a couple 100 microfarad capacitors that have the right voltage so they don't explode. Now, the ones that I have in the actual amp are all surface mount, and they're much smaller than these. How is this so large? 4.7, 47. Oh, boy. You know, this is going to be easier for me to search without you guys on the microscope. I'm going to have to do this. We'll just get close. It'll be less shaky anyway. All right. All right. Let's find them. 10 UF, 25 volt. Would that be acceptable in the circuit? I guess it's a 10 volt circuit. I guess it would be okay. Oh, and we need one anyway. There's one 10U in the entire thing. No, there's two. Okay, so I need two of these. So one of them, 10U, 100U. Here's 100U, 25 volts. So there's three of these. So I need three of these, two of those. This is the unfortunate reality of building something around here. Here's a 10U, 50 volt. That'll be plenty of volt. How many volt was you? You 50? You're 25. 25 or 50 volts. I think either one works. No, wait, this one's 25. Where did I get 50 volts from? Oh boy, I'm going mad. I'm going mad, guys. I think something weird is broken in my brain. So we got all the 10Us. We need the hundreds now, which are slightly larger. There's a 1U. Do we need other, what other small values do we need? That 100N is a ceramic. So we have one 10U, two 10Us, sorry. And then, that's 1, 2. Then we need three of these guys, so three of the bigger ones that are 100. 470. 470. This is what my stream would have been before the days of surface mount electronics. 100U, 50 volt. I don't need 50 volt though. We'll keep it real. 47. Let's keep it real. 47. Like looking through the Lego bin. The Legos bin. 220. $100U. That's two. I need one more. One more to go, and we're out of focus. Hello? There we go. I was hitting the wrong button. 100 Yule. Where could you be? No, too big. Remind myself of the size, then go back to the bin. Back to the bin. I will find this. 100U, 25 volt. There we go. Uh-oh. I think, did I drop an extra one? No. All right, so that's those. What are the other values of the capacitors that I need? I think there's only one more capacitor, and that's the ceramic one over there. Which means we have pretty much all the parts, except for a 100 nanofarad through-hole ceramic capacitor. I absolutely do not have that part. Unless I can find it, like, on this board right here. Unless I can find one on this board. What is this one? This one was for a joystick and it's digital, but it's got a couple, these won't even work in the breadboard. These are too short. I could probably find the part here though, but I don't think it'll plug into the breadboard. This is an old circuit that is for a little industrial joystick, but it does have a bunch of these little surface mount ceramic goobers on it. These are probably 0.1 UF, which this one is 100 nanofarads. So 100 nanofarads does not a 0.1 UF make. I do have there's another old, let me see, the old security system circuit. That thing might have what we're looking for on it. There's a possibility. Oh, dear God. Oh, dear God. I don't think I trust this thing. But I do have a couple ceramic capacitors on it. It is possible that I could find it. It's not, these are like pretty common values, so let's just see what's here. Why don't they just put the value of the part next to it? What we're looking for is a little bit of writing on the side of the cap that'll tell us its value. 2232. I don't know what that means. 2232. 2232. Ceramic capacitor. What? What is this? Mauser? No. Ceramic capacitor code. Calculator. Never really learned these too well. Maybe 223, 22NF. Yeah, either way, it's that's a very uninvolved website. Nah, it can't do it. What? That 2 is, I guess, maybe it's a tolerance on the end. (22NF) sounds right. I don't know. Oh, that's a Z. Yeah, that's not a 2. So 223. So 2.2NF. Yeah. 333K. Maybe. What? Well, wait. What value? We're looking for 10NF, right? Sorry, 10 something. 100 nanofarads. Which one let me work backwards from the code? None of them. So we're looking for a 104, which is a fairly common one, actually. We should be able to find that pretty easily. We're looking for 104. That should be fairly easy to find, huh? I guess we're not doing a lot of... Well, this one's chipped. That one has a big old chunk missing from it. That's 333. What is this guy? You move out of the way. This is part of an old intercom security system that was in this house that we took out when we moved in. All the remnants of it are pretty much gone because we had it completely covered over. All the holes that were in the wall for this thing. I don't know why you need an intercom in this fucking house. Like, I can hear when somebody, like, takes a piss on the 3rd floor. So... 223, man, they love their 2.2 NFs, don't they? They love them. They're putting them everywhere. Give me a 104. Come on, baby. Father needs a new pair of shoes. Actually, I probably do. What's this one? What do we got? Wait. That might be it. What are you? Where are they? I can't get it in focus. 102. Ah, you bastard. Oh, you 102. Son of a bitch. What are you? You're probably the same value, right? 102. Same circuit anyway. Damn it. It's a Z, not a 2. Sure as hell ain't a 4. It might be a 108, too. It might be 108. I'm looking for 104. That last number is pretty important because that's the number of zeros. Or the decade or something like that. Toshiba. Are there any other ceramic capacitors on this thing? I don't think so. Yeah, that's 2.2N. All right, let me see if I can find another piece of derelict electronics. Derelict my balls. All right, let's see. Another piece of derelict electronics that we might be able to find a through-hole capacitor on. Push comes to shove, though, I can just make a little surface mount adapter, which is annoying because when I do that, you don't know what the values of the caps really are, or, you know, you don't know what the value of the component is at a glance when you find it in a bin later. But I got a bunch of other stuff in this. This is a courtesy of my bin full of old electronics projects and stuff that have blown up and or exist for the sole purpose of being soldering practice. For like my nieces and nephews, and you know, when we run into a project like this, we're able to use this bin to kind of scrounge for parts. Unsuccessfully scrounge for parts. Yeah, these are going to be like power supply caps. These aren't going to be the right thing. All right, so we need 100 nanofarad capacitor. Obviously, it's not going to... Okay, it's not there. It's not there. So I got to go to the capacitor bin of surface mount ceramic capacitors, which I got a lot of. I have a lot of these things. All right, I don't know where the bin, if it's at the top or the bottom. I'm gonna try the bottom bin here and see what we got. What are that? Nope, that's ohms. That one is ohms. That one is microfarad. Here we go. This is my attempt to organize all of my variety boxes of parts, and it was a lot of work, and I don't think it was all that terribly successful. I don't think it's really worth it. So, 100N. I don't have nanofarads on this thing. I set the dial incorrectly. Let's see what it is in picofarad. 100,000, huh? And then that's, oh, 0.1 off. That's like the most, that's why 104 was so familiar to me. That's like the most common capacitor. I don't even need to look in this bin to find that. Well, here's 0.1 off. I should have 0.1s in through-hole somewhere. In through-hole flavor. Because those are just your decoupling and filter capacitors. That's just like the most common. I don't know why you would list it as a 100 nanofarad, because it's so much easier to just find a 1 microfarad. Why weren't there any on that circuit, though? Why weren't there any on that circuit? I need like through-hole digital electronics in order to find one of these caps. It should be super easy to find. I know I have bins of the surface mount ones. Why was it so hard to find? I guess they were using the 2.2s to decouple. Here we go. This one has them. I don't know their voltage properties, but this one was an Evil Mad Scientist board That was supposed to be a big LED driver. It was sort of the basis for the globe project way, way back in the day. It's decoupling the PSU. I don't know, man. But yeah, these should be 0.1s. They're a little small. They're a little small. I kind of wish I didn't install them into this board. Well, let's get one out of there. Let's get them out of there. So, get the soldering iron. Let's put the larger tip on it. Actually, that is a pretty big tip. And the cable is, of course, under a bunch of bins. What if they fall? They will render parts all over my floor, which is always nice. Soldering iron, thermal camera. Get all that stuff spooled up. Properties. Reactivate. That comes up. Chat's right on top of it. We should probably move you guys out of the corner, huh? There you go. There you go. All right, so I want to get one of these out of here. I wonder if these are 100s. If these are 100s, I'm going to be annoyed. No, they're 5K. All right, good. If those were 100, then I would have been like, we could have done this a week ago. All right, let's get these away before I spill them everywhere. And we will remove the capacitor from this circuit. I'm just thinking about whether or not I have a larger through-hole 0.1 off cap. I may have, hold on, I don't think I have a stash of the through-hole ceramics. I don't think I do. In the meantime, I also need the connector for the microphone, so I'm going to look for both at the same time. Not there. I think the connectors are in here, unless I threw them into the bin with all the other audio connectors in it, which I may have done. I may just have done that. It is possible. It's not there. Not there. Nope, 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 nope. Yep, there's, okay, so there are the connectors. But I ain't see no capacitors. The poor neglected LED bin. Yeah, so there's a difference between the capacitors. The ceramics can work in either direction. The electrolytics can only work in one direction. They have different electrical properties. And they perform different functions in the circuit. Okay, so I don't have those. That's fine. I don't have the through holes that I thought I did. That's okay. We will remove this from here, and we'll see what we can work with. Okay, sitting down again. Yeah, so how am I going to get that out of there? I guess a pick tool, a soldering iron, and a prayer. I was the one that soldered these things in here. I wish I was a little sloppier about it, and I left more lead space on this. Although, who would have predicted that 10 years after building this, Jesus Christ, 10 years after building this, I would be taking it apart and trying to salvage things from it. I've been wanting to build my own synth, but even this looks so hard. This is parts gathering. Parts gathering is an art. Parts gathering has its own little things with it. And honestly, like, if you guys weren't here, if I wasn't streaming this is the most fun that you can have with electronics. I mean, I'm going through old memories and like cool stuff, all the cool stuff that I have, and getting an idea of, you know, what exists where in my shop. Sort of my mind palace is being tickled. Tickle the mind palace. Yeah, I mean, I think this is all very worthwhile. It's like vintage shopping. A little bit. But yeah, you get to kind of experience your whole shop and figure out what you got going on around here, and what you're capable of building and whatnot, and yeah, just have fun with it. I mean, we're just hanging out today. We're just chilling today. So the only thing missing here are the resistors and the 100 nanofarad with the 0.1 off. I would really like to find like a big 0.1 off. You know, I have a feeling I have one somewhere. You know, like a big decoupling cap, like a big, thick, meaty, like veiny decoupling capacitor. But I just don't. I don't know what I could rip it out of. That's why I've got like these weird boards sitting around. But what about a monitor power supply? If only I had something like that. You know, like just like a power supply for like an old monitor. Oh my God, it's right there. Actually, wait, I looked at this. I don't see a lot going on this thing. I mean, there's a decoupling, there's an optocouple, there's a beard hair. It's definitely a beard hair, okay? It's definitely a beard hair. Let's see. We got these high voltage caps that aren't the right thing because they're performing a different task. It would be whatever this plugs into that might potentially have the decoupling caps that we would need. I don't really see anything in there. Capacitor plug is something else entirely. Actually, wait. If we're looking for 0.1s, then the board that I originally had would also potentially have them. This guy right here. They got to decouple somehow. Oh, they're doing the same thing. They got these little tiny ones. Damn it. Or no, those are for the crystals. You got any 104s on you, buddy? What are you doing here tonight? What are you doing here, circuit board? What are you walking through this neighborhood for? You come here a lot? Can I see some ID? I'm gonna need to see some ID. Yeah, these are 104s right here. So I can get one of these. One of these or one of these. I don't know which ones will have the better voltage tolerance. These look a little better. They're a little bigger. Oh, this one has long leads on it though. This one is the only one that has potential to be able to plug in. So let's see what we can get off of this one right here. All right, slaughtering iron. So this thing I've left on for like a month. It's turned itself off. If I press the I am still alive button, boop, we go from 0 to soldering temperature in a second. That's why I like my high wattage soldering iron. Soldering iron. This one gets a different cap. Well, let's pull this thing out. I need my pin tool. What happened to my pin tool? Why isn't it where I normally put it? Pin tool is an important tool around here. I use that for a lot of stuff. And if it's not in the bin, or you know, where I normally put it, which is where right next to the soldering iron, then I am lost. I'm lost. Huh, I don't know what happened to it. Well, I hope it turns up soon, because this certainly would have been a good opportunity for it, for the use of it. It's not on the other desk. No, the other desk is actually really clean. I didn't put it in the pencil bin, because I never do. It usually just goes right there. So it's probably found its way behind things. Very annoying when a tool that you use often disappears, because it sends you for a loop. You start considering the life choices that you've made, and you're alone with your thoughts, looking for this thing that you've lost. What have I lost all of these years? Ah! No, okay, I just don't see it. Damn it. I like that tool. I hope it shows up. It'll show up. All right, in the meantime, since I can't find that, I'll just use a clay working tool. These are virtually the same thing, only they're a lot weaker. What the hell's bang range? I don't know what the hell that is. Yeah, I'm not going super extensive with this, but we have done the legwork on this. Right now, we're trying to recreate my microphone pack, which is the thing that I have this lav mic plugged into, using phantom power through my Focusrite 2i2. And the EQ filtering that I do with it looks like this. Memorize that. Okay. No, it looks like this. This is the EQ filtering that I do. I want to replicate this, but in the hardware, so I don't have to worry about losing settings and stuff like that, and I can migrate the device from thing to thing and still get my high quality vocal optics. So yeah, that's what we're recreating. and we're doing it with Elliott Sound Projects. So there is an EQ in the Elliott Sound Project stuff, but yeah, that's what we're recreating. Anyway, I gotta get back to work here. I gotta get these 0.1 ups out. I've been talking about doing this for like 10 minutes now. It's dragging on. Dagron. Dragon. Okay. That out of the way. Wait, I see a capacitor over here. Tell me there's a 0.1 off in here. No. Of course not. I wouldn't have anything that functional and useful in my bins. Darn. There's a lot of electrolytics just sitting in here. I don't know what that's all about. Were these from when we... Did we breadboard the mic pack originally? Is that what's going on over here? No, that's 47. 100 F, 16 volts. I kind of feel like maybe we did, and I broke it apart and I put it in these bins. All right, enough investigation. What did you do? Oh yeah, I'll have to update that. Not doing it yet. I gotta work. All right, so yeah, let's get this guy out of here. So I'm gonna do this. What I wanted was the pin tool, because what I'd be able to do is put it in between the leads and just put a tiny bit of pressure on it like this. So all I need to do is just push down on this a little bit, and that'll pop this thing out. And I'll just drown the pins in solder in order to get this thing to pop out. The other pin tool would have been more reliable doing this. I'm more used to using it. How can I mean, this thing like naturally, there we go, just like that. There. So now all I need to do is keep my finger pressure on this. Yeah, they're technically sold as clayworking tools. I think they originate as dental tools, but the metal that they use is very terrible on them. So I'm going to do this the worst way possible, which is by loading the soldering iron up with solder. I don't have a free hand, so... And then we'll just go dupe, and then there we go. We got the part. We got the... Yeah, there it is. There's the part! I guess I soldered this with the same solder that I'm still using, so... It came off pretty easily. All right, back into the derelict electronics bin. You go. All right. So, I should probably clean the solder off of this thing. I don't need to. Does it still plug in? Let me straighten the pins out. My best tool for straightening pins is this guy. It's just because of the way the jaws are. I don't know why. It's just very good at it. It's very good at, like, locally bending the pins of stuff back into shape. Not really for any particular reason. I want to be careful, too, because I don't want to bend these too many times. Because I don't like to bend back. Hey, bell pepper. All right, there's our 0.1. Sweet. Next on the list. Next verse, same as the first. I need the pinout from the connectors. And then we'll get the resistors in here, and I can start building the circuit. And then I can plug into it, and you guys can see the difference in sound between the two. Of course, I'm going to have to plug the mic pack into the separate audio input so that we get the unfiltered sound when we do start doing the EQ, but... All right. So, I got a 5-pin mini XLR. That's what the mic itself uses. I don't remember what pins I'm supposed to use on the 5-pin mini XLR. So here we get to do open heart surgery on the very thing that's bringing you the audio right now. Oh, the other part that we need is the 10-volt Zener diode. 10-volt Zener diode. Hold on. Let me just do that real quick before we do open heart surgery on my own audio devices. So I only have surface mount Zener diodes. I don't have a lot of like through hole Zener diodes. So we need to make a little Zener diode adapter, which is literally just getting a 0.1-inch header and then soldering a surface mount part between the two. Between two of the little junctions. Now I have a bad order. I ordered these female headers that are not capable of taking a full 0.1-inch pin. I gotta make sure that they're the right ones, because those are the ones that I can use to make this adapter. Yeah, these are they. Okay. So what I'll do is I'll take that and I will clip off 2 of these guys. And that should hopefully not, it'll be a little bit of a dodgy, no, actually that's a pretty good connection to the breadboard. All right, so what I've done is I've now made a little perforated prototyping, well, not perforated, I made a little prototyping stand out of that. And what I can do is I can take the 10-volt Zener diode, gather round for a tale of Zener diodes. Day 1. All of the labels have fallen off. Dear God. What value are these? Okay. All right. 3v3, 7.5. Unlabeled. I take it that's these. There are multiple labels that are missing from this thing, though. 4.7, 5.6. No, this is the wrong one. I think. Oh, God. Hell if I know what's what. This one is mostly blank. Oh, my God. This is bad. This is bad. I don't know what's what. I don't know what's what. Hey, look, it's the 10-volt ones. But I have no idea if that's the right page or not. Oh, no. Oh, no. I don't know which one. I don't know where they go. Now, keep in mind, I did use a 10-volt Zener diode in the last project, so... These are, I don't use Zener diodes enough to really justify the amount of time that I'd spend with the label maker on this thing. 10 volt. This one? Is there one missing? No. $27 and $30. They do go in some order, so $30, $27, $24, down to 10. So I think we can trust that this one is 10. And so I'll take the 10-volt Zener diode out of there. That Zener diode is a... Oh, there's the pin tool. Hey, I found it. I told you it'd show up. It doesn't really get any further away than this, so... I know, we are kind of playing Guess the Zener diode, aren't we? Well, let's use this one and hope for the best. I actually think I might have, I actually think I might have, like, ordered Zener diodes or something. Because I don't remember putting a glass diode in this circuit. Only had kept this project together. Because I needed to build a second one for a long time. But the problem is, if I have a guest microphone, it's not going to have all the same filters on it. Like, if I plug it into the Rodecaster, then I can at least put a compressor on it. And then if it's got a built-in EQ, then I'll be able to equalize it properly. Because without equalization, this microphone that I'm using picks up everything. Everything. I don't want to touch my VSTs on it. So maybe when we plug into the other one, you guys will be able to hear what it sounds like with all of the audio frequencies active. But it certainly doesn't do the high quality voice work that I want it to. All right, so I don't think I need to change soldering iron tips. This should be pretty easy. Go to this view. There you go. Shaky, shaky, shaky. Come over here. And now I've got a little base that I can put my 10-volt Zener diode. The thing about Zener diodes is when you reverse voltage them, they have a specific type of breakdown due to the way, I guess they're baked, but they have a specific type of like voltage breakdown. They allow a certain number of volts through and everything else gets dumped. So they're very good at regulating voltages to a certain extent. They're also good as like safety devices for digital signals and stuff like that. So I'm just going to build up a little bit of solder in the cup. Yeah, it's how they're doped. That's what I mean. I'm not being very specific with that because it doesn't matter. Okay, this is more difficult to do with you guys watching. I remember when electronics had glass in it. They don't do that anymore. It's all plastic now. All right, you just do whatever you feel like. That's fine. That's cool. That's cool. We'll just do that today. Got her on. Hope the soldering goes all right. Thank you, Bell Pepper. I appreciate that. Good seeing you. Good on ya. Good onion. Did it? No, it didn't turn off. Damn it. I'm just trying to move carefully. I could do the thing where I just apply solder to both ends, but there we go. That's what I wanted. All right. Freakishly steady hands. I got steady hands. What can I say? Should have gone into surgery. Could have been a brain surgeon. I don't think you guys would want me surgerizing your brain. Flux. Flux is good. I don't know. You know, I got a love-hate relationship with Flux, and it's mostly a hate relationship just because of how sticky and awful and smoky and stupid it makes everything. I try to go easy on Flux. I try not to use it a lot. We're not supposed to be soldering. We're in a solderless breadboard. You know, solderless. We're not soldering. Although building a board would probably be a good idea, but build a board workshop. All right. Resistors. Well, that's going to be a thing of its own. I need to get stuff out of the way. Hold on. Jumpers. We can put away all the surface mount parts for right now. I'll have to organize that drawer later. Put away all the surface mount parts, because if I knock one of these off of the desk, I'm going to be nothing but a string of curse words raining down upon chat. All right, resistors, we got all of them. All the resistors. Resistors, yes. And we don't need shrink wrap today. Not today, anyway. All right, so I don't really have a panel to mount these sockets on. It would be nice if I did. I could probably like use the derelict mic pack maybe to make something that I could like hang them off of. Like if I did this. Well, I think the belt clip would really get in the way. Yeah, the belt clip would really get in the way. I mean, I could attach them to this and then put this up here. That'll be enough to hold on to the cables, but I'm not really sure. I'm not really sure what I want to do with that. I guess we could, yeah, let's do it. Let's make what the 3D model is, and I can stash it up here. These sockets up here are holding on to it a little bit, so they're holding on to it, so I can use that. Get all that stuff over there. I threw stuff around, and that made everything go in every direction. All right, so these 3D prints, they didn't turn out perfect. They just need a little bit of love before they start working again. A little bit of love. Let's see if my dimensions worked out from Fusion. And then what I'll do is I'll solder jumper wires onto this thing. Onto these things. And then I'll have the area that I can plug the microphone in. Hey, that fits perfectly. Look at that. Bam. Beautiful. Not exactly what the model looks like, but it's close enough. Hey, that's pretty good. I'm happy with that. Man, when you get spooled up with 3D modeling and a 3D printer, the world is your oyster, man. You can do all kinds of cool stuff. And in fact, I could probably have made these larger so that the infiltration of the pins isn't great. We'll see if I need to do that on the final product, because I only have so much room inside of this thing to build all of this circuit stuff. All of it. I gotta make it work. I think it'll work, but I might do like a bunk bed situation with this. Tilted the... I could make that a little tighter, huh? Because, yeah, this has the ability to tilt just a couple degrees in either direction. I should probably make that a little tighter. Shouldn't be gripping the threads, but I'm doing it. Okay, that's one panel. And then I've got the original screws for this thing over here, but I probably should look for better screws. I use like wood screws to put this thing together. We'll only be able to do 2 on each end. Screwdriver? That's up here. All right. How's chat doing today? Everybody's lurking. Everybody's lurking. Happy Friday, everybody. We're not taking something apart. That's weird, right? We're putting something apart. Wait, together. Yeah, that's what I was wanting to say. Yeah. I gotta do a number on these. These need to be a little bit. These need to be slightly different dimensions. Looks like someone's opinion has changed. What are you talking about? That's something that's kind of annoying on the internet, you know, where people try to do like the gotcha. I have virtually no EE experience. This is a treat. Hey, well, thank you for hanging out in the channel, Cannibal Jeebus. Thank you for hanging out in the channel, because I know, you know, you don't gotta be here. I'm not taking attendance today. You don't gotta be here, but I'm glad that the projects that I do are kind of interesting. Jesus Christ, these things did not turn out well. There's a lurking as usual. Hey, man, listen, lurkers are sacred. And people who watch the VODs are also sacred. Hello, everybody on the VODs. I appreciate you guys. Believe me. Yeah, PETG. PETG is a wonderful material, soda bottle plastic. It's very sticky. You can print it very hot. But there can be a tendency for it to pick up boogers and then deposit boogers all over the place, which is a bit of a problem. They actually do a number on your prints. This thing is so simple and thin. There's a little bit of support material under it, but man, can it be sanded? Yeah, I could sand these down, but like, why? It only took an hour to print the 4 of them. I'm just gonna toss these. It's not typical of my printer to do that. I just thought I'd show you guys what PETG can kind of do. You can commit to a very long print and then have it screw up in some places. Usually it's much better at doing this kind of stuff, so I don't know what was going on there. But I'll load up Red again and reprint it. It turns out the thing that we're building for Julian, I don't have to do 3D printing. I thought I could 3D print like the case for it, but I can't really find good files for it. And I'm certainly not gonna fucking tell you guys what the project is, because I don't want you guys to like read up the entire project and then come into my chat and tell me how to do my job, you know? It's so annoying. Can you recycle the plastic? I think you can. I think you can do it like once or twice. There are machines that you can buy that take old prints in, grind them up, and then re-extrude them into like a brown filament, which would be great for prototype printing. But back in 2019, you had a strong opinion of 3D printing as an adventure that's trying to do one thing. The problem is it's doing it really bad. Yeah, it is. I mean, what did I just show you guys? And I'll tell you something. The opinions change, man. Opinions change. You know? You get new information. New information, opinions change. I shouldn't be holding on to the threads like this, but I have to. I have to kind of twist it a little bit. But yeah, 3D printers, in my opinion, are still very bad at their own job. And you know where I'm going to talk more about that? Is on Cosmo Quest X. This weekend, Cosmo Quest X is having a hangout-a-thon, and so I have been contacted to come on the show for a little bit. So I'm going to try to... Tomorrow, I'm not going to stream games. I know I'm trying to get rolling on that game streaming thing every Saturday. But this thing came up, and I want to make sure that I'm properly prepped for it. I think what I can do is I'll do OBS webcam into oh, my brain hurts. OBS webcam into Zoom, and then have Zoom look at an audio cable, virtual audio cable, and then the output, the monitor audio from OBS will go to that same audio cable. I think that works. I think that works really well. I think. Yeah, I haven't been given like a room code or anything yet, so I don't know what the deal is with that. Yeah, man. My bread and butter. Doing segues. Are segues still a thing? I guess they kind of are. I don't know. You guys been around long enough to remember all the hype around the Segway? Some people like rumor that he actually wasn't gonna release the Segway. It was like some other project. But whoever that inventor guy is, this guy who invented the fucking insulin pump, for fuck's sake. But they were like, his new thing, it's gonna change the world, and everybody's like, it's like a grocery dolly that you stand on. So weird. And then some like baron buys the company that made the Segway, and the fucking guy drives one off of a cliff by accident and dies. Could you imagine dying on a Segway? You imagine you choose the hill that you die on is the Segway. You go, I own the company that makes these things, and this is the hill that oh fuck, and die. It wasn't the inventor, but it was the guy who like bought the company or something like that. All right, I'm clipping the leads on the capacitor so they're even. Otherwise, they're going to go in weird, and that really annoys me. I know, it's sad but hilarious. Yeah, it's one of those. It's a real funny sad. I don't know if I'd call it justice. Justice for what? I invented the Segway. How fucking dare you? What? Makes for a good story, I guess. I don't remember Bush wrecking a Segway. He did that? I don't remember that. I probably should. I was there for it. I was in the room. All right, we got to figure out what pins I'm using on this thing. You see, the thing is with the Tram TA50, TR50, the thing about the Tram TR50 is that if I can figure that out, then we'll definitely know what we're doing. Now, the thing about this microphone is that it has a 5-pin plug on it, and that 5-pin plug, I don't know what pins it's using. There's a specific way that these things work, where there's like another pin that gets grounded or something like that in the plug, in the other side of the plug, so that if you plug this thing into like a generic wireless transmitter or whatever, it knows what it is, and it knows what to do with the power and stuff like that, right? So anyway, let's take a look inside of this thing. I haven't opened this thing up in years. Yeah, it's a 5-pin mini XLR. Switchcraft sells these. They're very good. Very, very good. I mean, I guess the 5-pin would be for like stereo and stuff. But it's used in these kinds of mics. Yeah, here he is. There it is. There's the guts of the thing that's providing audio right now. Scary. Oh yeah, DMX too. You're really in the mini format too? All right, so those are the two that we're using. And that's, I think, all the surgery that I need to do. I'm not going to go into this any further. I would like to take a look at that Zener diode, though. Nah, I'll leave it alone. I got to leave it alone, because if I break this, I'm going to be in you know, up shit's creek. So let's get 2 wires here that are going to represent my audio out of the mic. Now, the red and the black wire, I guess I'll follow convention. So let's do red wire. Let's see if I can find a black wire that's long enough. No. Maybe. Yeah, that's pretty long though. It doesn't need to be that long. Well, it's the only red wire that I have, so I'm just gonna follow convention on this thing. So the red and the black wire. So that would be upper left with this one. That is actually very large for this connector. Well, it's for the test setup, so. No, it's an electret microphone. It has positive and negative on it. This is a polar microphone. It wouldn't work. So being that I followed convention when I originally built this thing, following it again means that I won't screw it up. I feel like I should be using thinner wire on it though, because I feel like if I bump these wrong, something will break off. Now we'll just go with the original plan. All right, black wire is in the upper left. I can't see what I'm doing. I'm too far away. Hold on. I gotta come down here. There we go. You know, it's a $150 microphone. I really don't want to blow it up. Which, you know, hooking this circuit up to it initially, that was stressful. That was stressful. I didn't have a spare back then. Why do I have Here I Go Again on my own in my head? I got like bar music stuck in my head, which is really a disaster. I ran into the tomato playthrough of Satisfactory. Ooh, boy. It was an interesting strategy from him to build all the stuff by all the resource nodes. That was a little triggering. I have continued to play Satisfactory like a freaking addict, and I'm up to nuclear stuff now. So most of my base is completely and irredeemably irradiated. Completely irradiated, and then all the belts filled up with radioactive stuff, including uranium rods, and have rendered an entire section of my main assembly area untenable for life. I can't be in an area of my base without taking damage. I had to keep using health packs in order to not die. I was like, come on. I was going to do all the radiation stuff off-site, but I decided to route it basically through the entire base, making most of the base a complete OSHA nightmare, which is hilarious. But now, as I'm trying to do more advanced assembly stuff, it's becoming a problem. The other problem is that the refinery stuff that I did off-site is not large enough. I didn't put enough refinery stuff in there. And so I'm sitting there like, what if I just break everything down and rebuild it again? And it's like, ugh. It's always something with these games, right? It's always something. Does the mic have other active components, or is it just a passive mic? They actually, so Elliott Sounds explains this really well. I haven't played all week. Lead underwear. Yeah, seriously. I used to professionally play with radioactive stuff. Hey, that's cool. That's kind of cool. Yeah, he explains it. I mean, they typically have like a transistor element in them. Yeah, we are an Elliott Sound Projects stream here, because this adheres to all of my steadfast rules about the internet. Is that if the site looks like it was made in 1998, it's a good website and it's worth using because it has a lot of good information on it. The other one that I like is the RF site. I forget what it is. Antenna Theory. Yeah, antennatheory.com. This is another website that was made in the midst of 1997 over dial-up. And oh boy, does this have a lot of good information on it. It breaks stuff down in terms that you can actually understand. I would love to be able to find something like a book that has information like this and the Elliott Sound Project's information, because these are resources that I am going to be very sad when they go away. We all thought that everything would be on the internet forever, up until recently, when it's been demonstrably when it has been proven that things go away on the internet. Things go away on the internet, and it's unfortunate that they do. You don't like the color scheme? What are you talking about? Don't you like pea soup? Pea soup and learning about antenna arrays? I am infinitely reminded of knowledge when I go to these weird ass color schemes. Look at that. Yeah, it's like the hot dog shop. What were they thinking? Yeah, each page is its own little weird color scheme to it. Art of Electronics is a good book, but I'm talking about the effect where you are buried in information in order to learn the basics. And that's sort of where, if you think about it, like that's really where the Arduino came into the scene and why it took over, is because in order to learn electrical engineering stuff and principles, people were starting to see that you could do a lot of really cool stuff. People were starting to see that you could do a lot of really cool stuff with electronics, including program stuff to react to things in your art, right? Your art could contain all the cool LEDs that would light it up dynamically and react to people walking by it and stuff like that. That was really cool for advanced cool art. But the only way that you could program it, you would get the microcontroller or like the demo board with a bunch of LEDs on it, and you'd be like, whoa, cool, look at what this thing can do. How do I use this? And then you go, oh, I need the programmer. You look up the programmer, it's $300, right? And you're like, how do I learn how to use this stuff? And you look at the textbook, and it's this thick, and it's filled with math problems. And it's like, as an artist, I don't need any of that, and so I'm going to actively avoid it. And so Arduino comes on the scene. Boom, Arduino. Well, I just buy that and I plug it into the computer. How do I program it? Oh, it's got this kind of basic language. It sort of hides all the stuff away from it. And all the engineers went, like little fucking babies. And they made their little poopy noise, and they started to say, oh, you're just blinking an LED. You could use a 555 for that. Oh, how do I use a 555? Oh, well, you need to do all these math problems, and then you follow this data sheet and do that. And it's like, I just plugged an LED in and I coded it while you were trying to explain that to me. Like, that's huge. And so what I'm talking about is having a tome of basics that give you the overview, that tell you how to use this knowledge in order. I lost viewers for making that noise. It gives you the basis of knowledge in order to use this stuff and to effectively kind of like remind you of what this stuff is. So sites like Antenna Theory, sites like Elliott Sound Projects, he's like, here's like a module that has an op amp on it, and it does EQ stuff, and you can plug it into like circuits if you need to. Things like that. Yeah, the angry engineers left. It's like, that sector of, it's like, I don't need to sit here and do transfer functions. I need to light up these LEDs so I can sew them into an outfit. You don't need all that stuff. But then, you give them the tools in order to get that stuff, and then eventually that leads to learning a little bit more of the depth behind it. It's a really good way to teach people how to, the wonders of electrical engineering and the stuff that we've known all along. All right, back to work. Yeah, rapid prototyping of the Arduino is huge. It's huge. It's huge with a capital U, 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 or G and E. Cool. We got our wires. Ooh, I was talking too much. I'm starting to get a little bit of heartburn. I had leftovers for lunch, so it's kind of a little bit of a heartburny affair. There was a pizza with mushrooms on it, one piece, and the heel of a shrimp po' boy. Just the heel of it, just a little tiny end of it, and one shrimp. One single shrimp. So this is going to be ugly. This is going to be very ugly, but it will allow us to do the prototyping that we need to do. Actually, are there ones that I already cut? Didn't I cut like a bunch of these for some reason? Oh no, I put jumpers on them. Never mind. Yeah, I was thinking like maybe I could cut the wires and then it would be a little bit more, it wouldn't look like this. This is weird. It looks really bad. But we're okay, I'm just gonna live with it. Just gonna live with it. Oh, wait, what are the pinouts of the XLR? Are they actually coordinated like I think they are? It's in that place I put that thing that time? Yeah, ground is pin 1. See, that's what I was getting at. All right, negative and positive. What are the colors that I got? Blue, white, and black. I got the 3 colors that are used internationally as grounds. Great. Building a PID temperature controller from a beer brewing using an AT-Tiny 85. I've got a Raspberry Brew in a control cabinet that does the whole electric brewing setup. I haven't brought that out in a long time. I need to. My grain is like 3 years old. Holy shit. I think it's okay. It might make a weird beer, but I've got the full indoor electric brewing system. The only problem is there's so much steam that it kind of causes my milling machine to rust if I don't I don't rust treat the whole thing before I brew. Hey, thank you for the 1,000 bits. I appreciate that. That's awesome. Listen, that's fucking great. I really appreciate that. Did something come up on screen? I hope something came up on screen for that. It's supposed to. Seltzer bottle. Sorry about the noise. All right. Something did. Okay, thank you. Yeah, brew pie. Brew pie is what I've been using. It's pretty awesome. I've had it for years and years, and I actually have a whole control cabinet with an emergency stop on it. It's actually right next to where I plug in the mic over there. I need to redesign that. I want to put it in a larger control cabinet and make it a little bit more organized and work for me a little bit better. That was the whole brewing table. That whole table that sits under the board behind me is supposed to be the brewing setup. By the way, if you guys haven't seen my channel before, which I know you have, Cannibal Jesus. If you guys haven't seen my my channel before, I have a board on the wall that's currently inactive, but we're working on it. We're working on the y-axis. When we get that together, get a little bit of programming, and then the thing should go live again. But when you sub to this channel, your name goes into a Raspberry Pi, and it gets processed. And the processing on the Raspberry Pi turns it into machine instructions. And those machine instructions get a blue laser to etch your name into a plank of wood on the wall. That project, the previous iteration of it, has been up for 2.5 years, approximately. More than 2.5 years. Yeah, there we go. It's been up longer than 2.5 years. When somebody says that, you know it's like on the just barely over. How does it map the live edge? It doesn't do shit right now. It's the software is the old version. We're going to work on that, though. I'm going to make a tool that will allow me to use a controller with the Raspberry Pi to do the X and the Y movement, and then maybe like hold down a button. And if I can get the laser to turn on at a low enough level to not scorch the wood, I can then trace where that edge exists. And then I can take whatever output from that, if we log the coordinates or the points or whatever. I'd probably rather it use a PNG image, because then I can just directly transfer it over to the masking PNG image, and then we'll have our edge. Yeah, it actually did originally. Originally, the laser pointer that we used, and the one in the YouTube video as the intro, is a laser out of an HD DVD drive. But over time, actually no. That one wasn't the HD DVD laser. It wasn't very powerful. Right? It wasn't very powerful. I bought a 1-watt laser, and then the one that we had, the glass like fell out or something like that, and so we replaced it with a 1.3 or 4, 1.3, and then I cooked it a little bit. I turned it up just a little tiny bit because there was a lot of good cooling on it. All right, anyway, back to what we were doing. Back to what we were doing. Ground is pin number 1. The wonderful thing about connectors like these, especially these nice switchcrafts, is that the numbers are actually on the plastic. You can kind of see it there. Maybe we can see it from the front. Look at my terrible 3D print. Oh, these aren't numbered in front. I thought they were. Maybe the 3D model has them numbered in front. So there's pin 1, and we can see it clearly right there. It's labeled in plastic. Maybe you guys can't quite, let me get the light on it just right. See that? Pin 1, pin 2, pin 3, they're labeled. So yeah, now we know where pin 1 is. There are no questions in our mind of which pin is pin number 1. So pin number 1 is ground. I'll just solder that straight on. Actually, if I solder that first, it's gonna get me in trouble. So let's make pin 3 blue, since that's what's labeled in this drawing. I'm just gonna pre-tin this a little bit. Pre-tin. The pre-tinning just allows me to solder it more easily. I don't think it doesn't feel like it worked. It would be good if I just turn this into like an audio test bed. If we're gonna do more projects like this, I need to buy more of these Switchcraft connectors. But it would be nice to have like a studio audio test bed. Because like one day I want to play with FPGA audio, and I think I could do like vocal filters with FPGAs. I don't like how long these connectors are. I mean, they're jumper wires after all. They're not really meant for this. But these things you can solder to like stuff, which makes them a little bit better. All right, get some solder on that. That one in there. You guys can barely see what I'm doing. Ugh, whatever. I'm gonna leave it. That was way too much solder. Ugh. Eh. All right, that one done. Yeah, the teensy stuff looks really cool. That does look really cool. But I kind of want to play with FPGAs. So overkill for so many projects, even CLPDs. I want to make a high-powered stepper driver that you can control using SPI. Yeah, it seems like it's a little bit far out for an FPGA. The FPGA that I have has been sitting here with no job. Friggin' freeloader FPGA. It was part of a Kickstarter. Where did it go? Is it over here? I don't think it's over here. Here's my teensy 3.2. So I mean, like, you know, this thing is an entire fucking computer, and I could probably fit it in here and power it off of phantom power, depending on what I'd want to do for the inputs and the outputs. But that's all I'd need. The 3.6 rather. I mean, here's a teensy 3 point something. This could probably also run all of my audio. Power that off of phantom power. But why kill when you can overkill? And by overkill, I mean put... Where did that thing go? I think this is a teensy. Yeah, that's a teensy. Where did it go? It's in here. It's in here. We just gotta dig it out. just gotta find it. Man, all these things are getting caught on one another. Oh, these could probably also do it too. These Raspberry Pi boards. Eh. 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 That's this. I don't know what the fuck this thing is. Eesh. Anyway, there's an FPGA in here somewhere. I don't know where it is. I don't know where it is. I lost it. My boy. I've lost my boy. Where are they? Nope, I don't think it's in there. Where the fuck did I put this thing? What did I do with my FPGA? I'm a bad FPGA dad. My son. Where is it gone? I don't think it's this board. No, that's an old Arduino. Nope, none of these. Okay. Well, it's in this bin somewhere. I just don't know where I put it. I assure you. I assure you. Oh, you know what? I think it, yeah, here it is. It was behind all this stuff. Yeah, tiny FPGA. This is a very, very small FPGA board. Pretty cool. It's like a $30, $40 thing, but it would be very cool to have this run my audio and potentially be able to be like a voice changer, run some advanced filters. Now, the teensy boards, these guys over here do it as well. It's just I have this FPGA board and I don't have a project for it. So I think it would be pretty snippy for this thing to actually be able to do advanced digital audio filtering and then output it in real time, and then have some kind of a UI that you could plug into in order to do all the filtering and stuff. But it's, you know, just thinking about projects. Anyway, one day we'll do that. Not today. We'll be very close to that, though. We'll be very close to that in this setup because I'll have the input and the output amplifier, and you can do whatever you want in between those. So that would be a time to run it into a chip that would convert it into I2S, which I think I have the boards for those chips sitting up on the desk somewhere. It's like way back there. Somewhere back there are the chips that I need. I've been playing with FPGAs and Verilogs a bit, and fucking Christ, is it confusing. That sounds about right. I should probably be putting my mic back together now that I know all the connections here. Let's go ahead and put the mic back together. We were in a dangerous spot there because I'm starting to need a potty break, and this has been taken apart like this. Let's staple this up before something bad happens. I really don't want to live in a world where my mic breaks. Yeah, there it is. That's what's bringing you this audio right now. It looks like programming, but it isn't programming. It's a liar. It lied to us. How could you do this, FPGA? I trusted you, Verilog. You were like a brother to me. I hate you. All right, that goes back on my belt, so I can't ruin it. Make sure we're tight. Yeah, I will not be machining a backplate out of aluminum for them. I think it's okay to be plastic. All right, let's put that back on my belt. Actually, yeah, belt's the best place for it. All right, so I got all my connections here, so I could move the cables over to here if I want to. I've got my Zener diode. I've got my. We need to look up the data sheet for this thing so we know the ins and outs, and so we can build up the entire circuit. Now, what I'd like to do is burp. Owie. Woof, that was a hell of a burp. What I'd like to do is set this up so that my ins and my outs are separated so we can put that extra circuit in there. Okay, that's cool. Yeah, let's just ow. Let's just burp hot fucking lava. That's cool, man. Thank you, stomach. That was great. I really appreciate that. The piece of pizza had pepperoni on it, and pepperoni is like heartburn poison. It's like the worst. I have to put a memorandum on pizza before stream, and pepperoni especially before stream, because that shit was evil, what I just experienced. Woo! Okay, got my ins and my outs. I can separate them a little bit. And then we can build up our circuit. Let's take a look over here. We're not going to do it right away, but I'm going to build this circuit. I'm going to build my microphone circuit, and then we'll plug it directly in. Because I mean, we're building up towards the EQ. So what we need to do is we need to build what's already here. I'm not gonna take the mic pack and like cut the trace on it, because I don't even know where the trace is. So, you know, I could build it in surface mount and then do that, but I think we should probably like spread out a little bit. So our thingy wingy is the MC4558. It's the surface mount flavor of that. We'll do data sheet. Yeah, no testing with a function generator. We do things a little fast and loose around here, man. I know you engineers are like, this should take months. No, we're just gonna get it done. And I already know that the circuit works, so. All right, so is this the, yeah, this is the same thing, the same package in all of them. So yeah, there we go. So now all I need to do is build the circuit. That's it. That's all I gotta do. All I gotta do. Just build this thing, just build it. Let me take this over here, and I'll put this up, I don't know, I should put this up on another monitor or something, but, well, all right, we'll just leave it here. We'll leave it here. Let's start with the microphone. So, start with the microphone. We need 10K ohm, 100K ohms. All right, let's get our 10s and 100s out here. Those are like surface mount better because I have bins full of these parts and they're easier to find. Oh yeah, and I gotta think about how I'm doing this. Well, like if I did things like a proper engineer around here, I would not have any viewers. There are a lot of streams that sort of do what I do. They probably do it better. They probably do it more like an engineer. But we need to play fast and loose with the rules a lot because it's gotta be fun. We gotta have fun with this. You know, I need stuff to be active and dynamic and happening, because a lot of the complaints that I get about this stream are that it's boring. It's really boring. You guys are boring. So am I. It sucks. All right, so the two grounds of both the XLR and the rest of the thing are actually associated with one another. These all share a common ground. So I'm going to use the ground rail for this. So we'll plug both of these into the ground rail. Then we have our input and outputs. The reason it's outputs is because it's balanced. We don't necessarily need to output to both outputs, but I think I did it just because. I think so. Let me check. I actually don't know. What in the goddamn holy hell was I doing in this circuit? I think I used the full balanced XLR output. Yeah, it's 3 cables. Yeah, it's 3 cables there. I got a 4-pin thing over here just in case I needed that extra ground pin. Yeah, I got 3 cables coming out of this thing. 3 wires coming out of it. So we're gonna build the whole circuit. We can't neglect some of the parts. Elliott Sound loves to do like, here's XLR and exactly how it works, and this is exactly the thing that you need, and this is the precision thing that allows it to work. Otherwise, none of this stuff would go together properly. And then after that, he goes, but you probably don't need this part, and you probably can't hear the effect of this part. And you're like, wait, wait, what parts do I need? Hold on, wait. What did you just say? Did you just say I don't need that op amp? Alrighty, so building the breadboard circuit. So we're gonna take, these are the outputs for the XLR, and I'm gonna put those just right here. Spread them out a little bit. That's the output section. And then this is the input section, which actually, to be fair, I will just put right here, just for the sake of keeping it clean. I'm going to put that right here, and then I'll jumper it away from where it is right now. Actually, we'll put that closer. We'll put that all the way over here. It'll signify that this is actually an input-output system. Those can move selectively when we actually start building the circuit. The star of the show is, of course, this guy right here. So I guess we need to put that down, and we need to just start building the parts of the circuit. Now, one of the parts of the circuit is a Zener diode, what goes from the positive of this thing to our voltage rail. Now, there is a voltage rail here. And the question is, should I should I power up the entire breadboard to 10 volts? That would be from here to here. That guy to that guy. Did you ever build an EQ with the extra op amps? Did it make any difference? I did the stream where we looked at the circuit like 4 days ago. What are you talking about? Did I ever build it with the extra op amps? I'm talking in generalities when I said about him, you know, Elliot Sound saying, oh, you don't need those actually. And actually he had it on the op amp based EQ circuit that I've only seen like 4 days ago. So no, I haven't, you know, when we originally did this project, I was focused on this. So. All right. Full cowboy? What does that even mean? All right. So we are building around this guy. We need a 10K ohm resistor from this to our positive rail, and then 100 nanofarad here. And then in addition to this, there's actually, it basically instead of R14, because R14 you're supposed to select in order to get this as close as possible to 10 volts. Instead of R14, we put a 10 volt Zener diode, is my understanding of how the other one was built. I would like to look at that circuit and see what exactly I'm doing, but I think the Zener diode regulates the power a little bit more tightly and probably makes it work a little bit better. It's not really so much a workaround. You know, I've seen it on its other projects, I believe. I think it was on one of his other projects. I'm not sure where. I don't know where it is. All right. Anyway, we gotta build this. I gotta do work now. So from our microphone in, we've got the 10 microfarads. So let me get that capacitor out. Got the 10 off, and then this diode doesn't go there. We got the 10 off, and the positive is facing towards the microphone. The band on the capacitor is negative. If you guys don't know that, the band on the capacitor is negative. It's a nice simple way to signify that. On the surface mount version, they've got all kinds of schemes for printing it. The unfortunate reality that we live in is that a capacitor has to be a certain size. It's just the way physics works. So when you get to like 10 offs and stuff like that, you know, they've done their darndest to miniaturize these things, but there's not a whole lot that they can do. So one of the biggest design elements when you're working in stuff and you're trying to make stuff small is the size of the capacitors and how you're gonna put them on your board. A lot of times, what I've seen recently was originally a no-no in circuits, but putting banks of capacitors next to each other. If you wire a capacitor in parallel, you can think of a capacitor as literally 2 plates, because I mean that's the symbol. The symbol is literally just 2 plates, right? You got 2 plates. If you put 2 more plates in parallel to those plates, now you've got 2 larger plates, so it just adds up. And then in a weird turnaround of the way physics works, if you put them in series, they work like parallel resistors. You do 1 over the product of the values. It's a very strange relationship between the two. Very strange relationship between the two. All right, so I take this, I plug that there. Cool, we're done. We did it. We built the circuit. Congratulations, everybody. You did it. We did it. We built the circuit. We did it. There it is. There it is. All right. Good work. Good work, everybody. Good work. Good work. I'll see you guys next week. A capacitor bank is a no-no because there's a possibility that one of the caps goes bad and then your value changes. It's kind of it's a no-no in the event that something might potentially fail. This one gets the 100 nanofarad. That's this guy. And it goes to ground. So this is the entry of audio to the rest of our circuit. Let me move that like this. So I'll go over the gap with that capacitor, and then we can treat this area like that. Yeah, I guess so. There's a couple things that need to connect here anyway. Oh no, the 100N goes between... So there's a 10K that connects this to positive, and the 100N that connects this to negative. That's going to be a little difficult to do. All right, so let's get a jumper in here. A yumper, if you were Rabaz. Damn it, I just... Okay, fine, whatever. Fine, whatever. Just get destroyed by me trying to pick it up. Tweezers are helpful when doing breadboarding like this. Perfboarding, I guess you could call it. Yeah, breadboarding is fine. Calling it breadboarding, fine. As we put this together, the shape of the circuit's going to be more and more clear. These things can tend to be a little bit sloppy. And so there's a certain point, like I was saying earlier to the guy who was having an electronics problem and wanted me to personally help him. I love that. You know, I'm sitting here trying to entertain hundreds of people, and people are like trying to get me to do their homework. But yeah. At a certain point on the perforated prototyping board, you build the circuit and it's all over the place, right? Everything is everywhere. Nothing makes sense. And it's a big ball of wires. Malphabeth, thank you for following. It's a big ball of wires. And looking at it gives you a little pit in your stomach. At that point, you take that knowledge, you break everything down and you rebuild it. And oftentimes, that will have a very good result. That wire was ground, and I need a 100K to go to this. Wait, that's between power and ground. Wait, so this goes... I guess this will just go here. Oh, of course the gap is right here. God damn it. All right, I'm going to move this over. I guess this just needs to be in, like, proximity to the electret. So like that, and it literally just goes between our power rail and ground. All right. I'm not going to question it. I am going to question it. It's weird that it's just decoupling power and ground. You would think that it would have to be closer to the chip. Is that what he intended, actually? Did he intend for this to be closer to this chip? Is that why that's there? Because I thought it was associated with a microphone. If you intend for it to be close to the chip, you should move it over and have it like hang down off of this line or something like that. That's what that would communicate to me. It's possible that that's the intent. Let me go under that assumption. Let's move under that assumption. So I'm going to move that 100 out from there. This will go to the op amp. This will be close to the op amp. Which makes sense, you know? Hello? Ugh. And then let's see. We've got ground coming in there. It's actually not necessary. We have power with a 100 kilo ohm. So that's pulling down the 100K. All right, so we'll pull power in here. And then I'll put a 100K between these two. Actually, I could just jump the 100K directly over to power, so I'll just do that. All right, 100 kilo ohms. 100 kilo ohms. Where are my resistors? What happened to them? Oh, they're right next to me. 1K. 100K. I think these are not labeled. Oh, these are 10K, actually. These are 10. Where's my 100? These are as organized as I think you can get them without putting them in bins. All right, let's get rolling with these. My surface mount collection is so much better organized than this. Wait, what is this one? Oh no, these are, okay. Try to keep them in order. 4M, 2M, 500K, 220, 180, getting close. 150, 100. We found them. Where'd he go? There he is. Okay. 100K. So how many hundo Ks are we going to need? Oh, it was actually 10K. Shit. Well, we still need 2, 3, 4 100Ks. So let me get those right now. We need 4 of them. Funny that 4 would be missing from this. I've already built this circuit many years ago. Actually, I think I surface mounted it first, to be fair. All right, 4 hundo-Ks. Let's hope we remember that that pile is 100s. Yeah, no, I never learned how to read the stripes, believe it or not. I never learned the stripes. I never thought it was necessary. I live in an age of surface mount electronics where the value is simply just fucking written on the thing, you know? That's how I roll. Okay, so this one's a 10K. So there's our 10K. And I'll do the thing where you bend one lead down like this and then clip them even. If I can find my clippers. There. Clip them even. And then that just goes in here. So there is 10K to positive. We've got a 10U on the input. And then we need hundo K and another hundo K going down on the other side. Jeez. This is a weird circuit, man. This is a weird circuit. So I got 100K and then another 100K to ground. So I guess I could do that down here. I could just jump it over one slot and then I can go down to ground. I don't know a whole lot of tricks and trades, and I don't know a lot of tricks with perf boarding through hole. I'm not too familiar. I've done it a lot, but I don't know all the lessons. So anyway, that's 100K to ground. Oh, that's not supposed to be on that pin, so I'll move it one over. There's 100K to ground. I really bend those leads so that it's a little bit more organized, but we'll just roll with it like this. So I got 100K going between the capacitor and ground. What's up, might be jerking off? Hey, you've been here for a while, actually. I see a Robot's emote and I say hi. Hello. Is he streaming today? Has he actually learned to stop streaming 500 days a week? All right, so where are we? What I've been doing is I've been going through from this side over. And so we've got that I put the kibosh on. We've got this guy here, we got this guy here, we have this one here, and we have this one here. So we need to move towards our actual op amp. So what I'm gonna do, let's see, 33K on that. See, I don't know what this line is right here. I don't know what this is doing. This is like his virtual ground or something like that. I don't know exactly what he's doing with that, and I wish I had an explanation of it, because in some of the instances, he talks about deleting R9 and then making R8, or so I think it's R9 is just a jumper and R8 is deleted in order to make this unity gain or something like that. Yeah, it's like a reference voltage. It's strange. It's weird that he's making it from the mic reference. I don't know what that's doing to everything else. It's very strange. Op amps are weird. Okay, so we have established where that this line, we've got it. It is a virtual ground. Interesting. Yeah, because we got a 33K here and 100 micro there too. And that one's sitting on that line. Strange. So 33K and 100 microfarad to ground from that junction. That junction is right there. Man, I'm gonna run out of posts to hook that up to. Oh, that's responsible for the Q value. But this isn't an EQ. It's just the Q value of the circuit, I guess. That is a Q value. I thought a Q value was just how much it Ah, whatever. I don't know what I'm talking about. All right, 100 micro. That'd be one of these. Positive facing up. And then we're going into this junction here. And that goes to ground as well. These are in parallel. So I guess what I can do is just kind of fudge it like that. And it's like everything is on this. I don't like it. Everything's on this one line. I'll just bend the capacitor over like that. Just bend it to my will. How I see fit. This thing is just a voltage amp. I've made this circuit before many years ago. Many moons ago, I've built this circuit. This is in fact the circuit that is feeding you audio right now, and the reason that we're building it is that we're rebuilding it. We're rebuilding it so that I have it on the test bed, so that we can punch an EQ into its tits. You don't really drive anything through XLR anyway. What do you mean? What you mean? Bias the reference halfway the voltage rail. Interesting. Bias the reference. Huh. All right, anyway, I'm going to, let's see, we're done that, we've done that. I need some 33Ks. Remember that these are the hundreds, the ones that I lost. Where do they go? Oh my God. All right, these are the remaining 100s. Those are the hundos. One hundo. We need 33K. 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 I kind of want to do a gaming stream tomorrow. It depends on how I feel. I'm not going to make any promises. I kind of want to just like goof off and play a game tomorrow. But I don't think you guys would be able to tolerate more satisfactory. I can't play any other game right now. No, I can. I may do Long Drive just because it's a really goofy game. It'd be a lot of fun. I can't do Long Drive with the wheel, though. I'm not going to set up the wheel tomorrow. I like Satisfactory. I like that game. It's a good-looking game. It's a fun game. Listen, if I play... I really want to break down my entire base and rebuild it. I want to rebuild that whole thing. I want to rebuild that whole base. I've been playing the game for like 119 hours in the past 2 days. And I want to rebuild my entire fucking base. But that's such an undertaking. I have a completely different idea for how everything should go together. How many 33s do I need? 1, 2, 3, 4, 5? No, 4. 5. I need 5 of these. No rebuild, only hack. I know, right? You either rebuild or you become the spaghetti monster. There's no in between. Tomato's playthrough was particularly triggering, but he did stuff like in the way that I used to do it, which is by creating the material right next to right next to where it's being mined. So you mine what I used to do, and I still think this could be a good for a playthrough, especially on the desert map, where you take the ore out of the ground and you smelt it immediately. And if you need more, then you make more smelters in various areas. But instead of just mining it, you put down foundations, because believe it or not, those miners, they can sit on a platform and it'll extend down to where the thing is. There's actually a lot of leeway there. So I was like, I'm gonna build a building at every site. Maybe that's not a great way to do it though. But yeah. How are you gonna contend with the nuclear wasteland you created? I know, right? I'm wondering if I can just go in with a map tool and just delete everything. Just delete everything and keep my progress. Just have a mulligan, right? The mulligan event. Like, hey, let me get a do-over on that. Hey man, can I get a do-over on that? That'd be great. That'd be really nice of you, you know? You know, you just give me another chance. Just give me another chance and I'll make it right. let's say this. If you were on a different planet at the behest of a corporation mining, they're not really mining. They want like advanced materials now. I got to make some weird stuff. Will they let you rebuild it? Or they feed you to the tall crows? That's, you know, that is a point. You have a point, sir. Sir and or madame, you have a point. Is that Fix-It would not tolerate that kind of shit. Fix-It is a very hands-off company, though. They pretty much loaded your dumbass into a pod and shot you at a planet and say, hey, we could really use some smart plates up here. And you're like, all right. All right. I guess all right. I guess I'll do it. So yeah, all right. Where do things go from here? Where do we go from here? Well, we need our op amp. And so I'm sort of like clearing stuff around here to place the op amp. So I guess I'm going to put the op amp. I really want to, listen, chat. Look at all the space that I have. I need to spread out. Spread out. Use all the space in your board. Because things are going to get kind of hinky when you start to try to really cram stuff together. I'm almost even tempted to just put the capacitor here and then jumper over to it, just to spread out more. But all right, let's go all the way over here. And let's take a look at what we're up against. So I need a 33 kilo ohm resistor, but if I go here, and that 33K and another line are going to be my inputs. Actually, I think that's a little too far away. I need to move up a little bit. I'm going to move up a little bit. Ugh, the circuit's going to be like stupid and compact. Where are we? Here we are. There he is. So pin 1 is labeled on this little breakout board. Sorry about the shaking. I don't know why we're so shaky today. It's like I literally have to not. Okay, that is not me. That is a latent oscillation. I'm not touching this at all. Stop it. Oh, you fucking thing. You know, we got rid of a lot of the vibration when I upgraded this thing. But it is all over the damn place. Fucking director of Star Trek is over here. Making us do shaky cam. Why are you like this? Stop it! It's just shaking. I don't know what's causing that. Why are you doing this? Nothing is like this camera doesn't shake. That one is just so sensitive. It's like you guys have to know that like that camera here. That camera is all the way up here. It's not even like close. Like, why is it shaking like that? Where are you getting this vibration from? I need like a damper on it or something. I think a lot of it has to do with this right here. This is on a spring. And I would like to get rid of that spring because I feel like that's probably causing me a lot of my issues. Yeah, see there's like an adjustment for that piece, but it should be adjusted all the way down, but it's not. This is meant to be holding a measurement device, not a camera. So all right. Anyway, all right, so we know where pin 1 is and all that stuff. Let's try to avoid the microscope because it's not cooperating today. Yeah. On this thing, what is our pinout? That would be I think that's this. Yeah, there we go. Pin 1 is an output, so pin 4 and pin 8. Pin 4 goes to ground, pin 8 goes to positive, and then we put the decoupling capacitor nearby. So let's get that done. There we go. All right. Now you guys can kind of see what's going on. I wish I had the microscope view. So pin 8 is where power comes in. So I will put this decoupling cap up here. I'll put it right up here. And since this thing is so short, I have to kind of put it right like that, and then I'll have to jumper across or up to ground. So I gotta, let's do 2 jumpers right here. All my grounds are bussed together, but that creates a lot of noise, so I gotta be careful about that. We've had that noise affect other circuits, the noise of the prototyping board. Yeah, you know, every now and then, one of these things just fights you. All right, there's that. More jumpers. I'm trying to use up the jumpers that I had previously on this thing. Previously on, oh bother. All right, there's positive power and ground. And then I need a ground connection on the other side. There you go. Ah, back. Ground on the other side. All right. And then, oh, this is the 33. So this 33 connects to the input. So we're going to do input on this side, output on this side. Yeah, I do the procedure every single time on the camera. I've actually automated it with Stream Deck. Stream Deck and Node-RED connected to OBS. The Node-RED flows, since Stream Deck, the bar rater tools, can't do anything about the frame rate. They can't change the frame rate, but OBS with the OBS WebSocket plugin can change the frame rate. So I've put that all onto a multifunction button on the Stream Deck, and I push it, and it does the whole procedure to the camera. And then my cameras work brilliantly and give me this wonderful, wonderful video. So I'm able to use some very cheap things to create beautiful, wonderful visuals and audio to stream out to you guys. Output number 1. Inverting, non-inverting. Man, op amps are like math magic. I don't know how the fuck they work. They're math magic. They're math magic that you like feed it back into itself and it becomes an Ouroboros of fucking nightmare math. It's ridiculous. No, you can't say that. How dare you fucking say that on my stream? All right. Pin 4 minus. Pin 3 plus. Let's look at the circuit again. I'm trying to, there's a lot of information here that I got to get into my brain. So pin 3 is supposed to connect to the 10U and the 100K. That's not pin 3. Actually, yeah, it is pin 3. Wait. Do we have the same pinout? I think we have the same pinout. Okay, so I can just trust the numbers on this thing now. Cool. Well, that's good. That's good. Physics math? Well, at least in physics, you can assume a perfectly uniform spherical horse. You know? Spherical horses are important. So over here, let's see, what do we got? This is like, unfortunately, this is a lot less clear than it is on the drawing. Like, if I could reproduce the schematic with all the connections like that, that would be great. That'd be great. That'd be so easy to troubleshoot. But instead, I got to remember what I was doing 10 minutes ago, and I'm streaming right now, guys. It's like a pretty big mental tax, streaming. It's tough to do this stuff on air. We've got the 2 100Ks. One of them is coming from our signal source. And so this right here, this path right here, is what I need to move over to the op amp. And I can go down and around that way, or I can just try to jump it straight over. But we need to go to pin 3. So I'm thinking down and around is my best bet. Let's see, this one is a 33. I got to make sure to put this in the right one. So down and around. Simulation is fucking cursed. You shut the hell up. Don't talk to me or my son ever again. Simulation sucks. No, we work in the real world around here. I hate simulating circuits. I really do. I really dislike it. I really dislike it. And that's purely PTSD talking. That is purely PTSD talking. Back in my day, we used to use Spice, and those programs are, as far as I'm concerned, a practical joke against engineers by programmers. because that fucking piece of software was LT Spice back in the day. That was so cursed. You're like, you click the button and it says your simulation failed. You click it again. Simulation failed. You click it again. No, dude, simulation failed. And then you're like, motherfucker. And you click it again and it's like, okay, here's the simulation. You're like, wait, what did I do differently? And the program's like, I don't know. I don't fucking know. I need a circuit simulator that's like satisfactory. I needed to have the same graphical, you know, cleanliness. I put down a bunch of foundations and then I start building my circuit on top of it. And then my inputs and outputs are like stuff on belts. I hated LT Spice. It's so clunky. Why does everybody throw LT Spice out at engineers, you know? You would think that we'd be a little bit better at that kind of stuff. Fuck, if there was a category of games, cough cough, factory games, where you could work with that kind of stuff. Yeah, do all your prototyping in Minecraft Redstone. I hope you prototype in Minecraft. I can't believe you said that about me. This is a terrible line. I don't like this at all. I don't like this at all. I mean, I could move that closer, but I could move that closer. Hold on, let me see. I could do a multi-jump. The problem with my jumper kit is that there are certain lengths that I just don't have. Yeah, like the length that I would need in order to move that signal over cleanly. All right, we're going to leave it the way it is then. Fuck. I guess. What I'm annoyed about is that the output... Where's my finger? Vsauce, Michael here. Where are your hands? This is the output. It goes up that way. So, I don't like that. All right, anyway, let's keep moving here. Let's keep moving. So 10K, 100 nanofarad. I got the 10K on the input. I got the 100 nanofarad. That's right there. That's all wired up. My op amp has power. We've got the one signal coming from C3 and the virtual ground, the two 100Ks. The virtual ground isn't done yet. I still need to do 33K to power. The 100U is in there. So let me do the one to power now. It's hard for me to do good visuals on breadboarding. It'd be nice if you guys could like kind of know what I'm doing, but this has to connect to the same thing and it has to go to positive. I could do it like up here. I could just do this. Yeah. I actually have a tool specifically for this. This thing right here, this piece of plastic. This is specifically for this type of thing, where you release this, and then you take it and you go, I'm going from here to here. So if I was doing this, going from here to here, put in the holes, tighten it up, and now all I need to do is bend these down. Clip the excess. Now that goes all the way down there. Perfectly. Where am I connecting to? The 100N? Or sorry, the 100U goes to, yeah, it goes over to there. So I'll be going to here, and then this one's here. That is too compact. That is too compact. I'm going to spread this out a little bit. I'm going to move this down a row. Actually, a bunch of rows. Let's go like all the way over here. This one should probably be flat as well. I'll just do that. Just to open up the circuit a little bit, you know? So that can sit like that. And then this could actually go on top of it. Or I could do something weird where I bend this pin over and down. That'll clean it up a little bit. And then I got to clip the leads so that they both sink in properly. I don't really use that tool a lot. It's decent though. It does its job. Oh, come on. There you go. The holes were fighting me there. Okay. like that. And then this one I'm going to spread out a little bit. Clip the leads on it so it's nice and flat. Use the tweezers. They're easier to maneuver. Easier to maneuver into this thing. Maneuver. I've had like a weird dry spot on my hand. That's weird. Just noticed this like spot on my hand, on my mitts. Come on, man. Like that. Please position yourself properly. I don't know why I'm having trouble with the small stuff today. Usually I don't. Okay, that's like that. And then this goes from 33 from here all the way to positive. Looks like it's a little short. It's a wee bit short, but that's a lot more clean. I don't know, the tweezers help, but maybe I am making it a little hard for myself. You might have a point. You may have a point. Now, technically, I could make that a lot cleaner by... Oh, no, but I still need the positive. So jumping over the center is probably a good idea anyway. Negative was facing this way. It's funny how you mark it with a plus, but the negative is the one that's marked on the actual physical part. There we go. All right, we're a little tighter to the board. Things are a little cleaner. I'm going to clean this a little bit too. Clean that one up a little bit too. Make it a little bit more compact. Anyway, it makes me feel better about the circuit. Ah! It attacked me. You all saw it. Really, if I really wanted to clean this up, I could take, I could move a jumper over there and have this sit over here. I'll do that. I'll do that. It'll just make it look a little bit more display worthy. There's a balance between having a big bird's nest and having a nice organized layout that you can at a glance troubleshoot. Yeah, that's much cleaner. That is so much cleaner. Your meat tweezers provide more feedback. I don't know what kind of tweezers you got, man. I don't want to have wires going every which way because this is going to be hooked up to a $150 microphone. So I really want to keep this thing nice and organized and neat and clean. If I could color code these resistors like by spray painting them, I would. Next. All right, what are we doing? I am connecting the negative to a 33K to that same fucking line that everything is on. Well, this is the last connection that it gets. Oh, I see why I was short. Because I went to the wrong pin. I only got 5 connections per junction. Otherwise, then I have to bust it outwards. And this is another principle that comes to you thanks to Satisfactory, which is if you're doing power lines, every single device should have its own junction with multiple inputs and outputs. But that's a Satisfactory thing. That's not... What? Whenever another student asks me to look at the breadboard, it's a mess of wires. Yeah, we did a wire wrap project that was like that, and I had to build it in like negative time. I had to build it in like record time in order to let this guy write our paper. So yeah, we're going over to here. Yep, I don't have to guesstimate. I can just do it up on this thing. Look at it go. The problem is I'm blocking a lot of lines by doing this, but I think it'll be okay, hopefully. So that's our virtual ground. Ah, crap, I did a bad bend. I don't know, bending these with tweezers is probably a better way to do it. But, I'll humor this thing a little bit. All right, so that goes from here, which actually is tough to do. I need to move this down a little bit, so I'll just take this. I'll move it up. One thing that Satisfactory did to me the other night was it randomly, certain things randomly stopped working, and I don't know why. I think it was because of belt layouts and stuff. But like I had a part that was feeding in, and then it just like stopped. I was like, why is my bin not refilling? They used to use wood boards. That's what they used to do. Oh, that's literally what you said. Sorry. I used to print schematics on paper, then glue paper to a wooden board. Then I used small nails and connections, soldered components and wires to the nails. That's a cool way to do it if you're doing like a display. You're doing like a school project. That's a really cool way to do it. Sorry, little heartburn cough. Do I have liquids? I do. Seltzer. It's like drinking TV static. Oh, because the boards that bread came on or something like that is literally what they would use. Yeah. Grandparents' multimeter got when he passed away more features than a €100 modern multimeter and was 40 at the time. Holy shit. Old tools are really good. Yeah, they would nail or screw components and connections onto a literal board that bread came on. And this is like in the early days of electronics. It was the beginning of standardization. And unfortunately, some asshat decided to use inch standard with electronics. And so now all of us EEs out here on the front lines actually fucking building stuff get to work in both inches and metric. Apparently, inch was decided upon to be the absolute end-all, be-all, see-all of engineering. And it's really annoying because when you go from through-hole to schematic, through-hole stuff is all standardized at 0.1 inch. Surface mount is not. It's oftentimes very metric. So it's just one of those things. But again, if you want to know what it's like to build a circuit board, just play Satisfactory or Factorio. Aside from defending yourself from aliens, which is, maybe that's kind of an office situation. Yeah. It feels very similar, which is why I've put a zillion trillion hours into the fucking thing. All right, so what are we doing? We're doing what we got so far. We're like here, right? I got my 33K going to the virtual ground. I got this, I got that. There's another connection on the virtual ground, so I'm gonna have to actually move it out because there's no more available lines on that. So what I'll do is I'll move it to the one next to it, and then I'll put one of the micro jumpers on it. I guess, or I could take one of these lines and turn it into that ground, but I don't think that's going to be good practice, seeing as I've typically got everything bust. Is that one? That one's not bust. Actually, we could use this as the virtual ground, but that would mean I need to rearrange everybody if I did that, so I'm not going to do that. Instead, I will put a micro jumper. Look at this little guy. Look at this little guy. He's sus. Look at him. Okay, let's put him in. Look at this little sussy bussy. All right, let's take this one out. Actually, yeah, we got to take that one out. Oh, and that means that my capacitor can look proper. Oh, no, it can't. Damn it. Wait a minute. That doesn't work at all. Oh, the gap is right there. Damn it. That would have been nice and clean, huh? Nice and clean. Go. Where's our sussy bussy? There he is. No, come back. I'm sorry, I yelled. There he is. All right, so that gives me more lines on the thing. Most are Imperial and SMD work too. BGA packages are an exception. I like working in my millimeters. I like my working in millimeters. All right, what's next? Basically, the rest of the circuit is 33 kilo ohm resistors, huh? So we got the 100U, we got the 33K to positive. That's this. We got the 100 ohm coming in. And the 100 going to ground. And we got the 100 micro to ground. And so this connection also goes to the other side of the board, or other side of the chip, on pin 6 through a 33K. And the 33Ks are over here. 33K, 1, 2, 3, 4, and you go over like this, 5 and 6. So this is the one. This is the one that I want. How do I get over there? I mean, I could run it flat along here, but then that exposes it to these pins. I don't think I have much of a choice but to do that, but I'll do it up in the air a little bit. So if I do that, that's too close. All right. Give it a cut. I mean, I actually could have probably just like jump this over to here and then just put the resistor, but it's too close. I can move the decoupling cap off, but then it's, no matter what, it's like way too close. Thinking about that. I mean, pin 5 is here. There's still a whole nother pin that has to come out of this thing. So here, let's do this. Let me get the tweezers so that I can do the bend properly. Yeah, I can put the resistor right where it's supposed to, right where it'll insulate the lines. This is kind of an art form in and of itself. All right. Nice and simple, right? I try to make my circuit builds kind of artistic. Here, I'm going to move that capacitor up a little bit. I need to find a jumper. A yumper. There you go. Put the jumper in here. It's unfortunate that I'm building it on such an ugly board, though. It would be nice if this was made out of, like, black plastic or something. Or, like, a texture or something. I don't know. It's not ugly, you know? Move that up. Ugh. Ugh. There you go. And this goes like this. And like this. There we go. Clean. Clean is the name of the game. It's how I do everything. I gotta make sure that it's nice and clean. Because the cleaner it is here, the easier it's gonna be to troubleshoot. Okay, where does that get us? Well, now I need to go from pin 1 to 2 with a 33 kilo ohm resistor. Well, that's easy to do. And cut these nice and short. Pop. Pin 1 to 2, 33 kilo ohm. Done. That's our feedback resistor. From pin 1 to 6, oh, pin 1 also goes to 100U and then 100. Oh man, this is a lot of connections. This is a lot of connections. There's a lot of connections here on one singular thing, right? So I got the feedback resistor in there. It seems like now I should probably move it out from the chip, because I've got to connect a lot of stuff here, and I don't have a lot of stuff. I don't have a lot of holes that I can get to. I mean, it's 1, 2, 3 connections. It's actually not that bad. This isn't weird. This is awesome. This is the amp for my lav mic. It's the one that I'm using right now. And it's why you guys get such beautiful, dulcet, buttery tones out of my voice. But we gotta translate all that butteriness into a circuit that we can add an EQ to, so that I can remove this mic from the software that I use. I would like to be able to plug in this mic and get this kind of frequency response everywhere I go. was like, what is that word? Is that some kind of weird Britishism? No, buttery biscuit base. I don't know. Is my voice particularly bassy? Stuffing butter into your breadboard. Yeah, it's true. It's true. There's a little butter left on the breadboard. That's what we're building into the circuit. Not too bassy. Good. Good, good, good. Macho voice. This is my macho voice. Hello. All right. All right. Stop saying weird stuff about me. Fuse box. Oh, we're going to be familiar with that in a minute. Thank you. All right. 33 kilo ohms going into pin 6. And then also out. Yeah, I spent a lot of work. Tuning the audio of this microphone. Everything gets into the mic, but you know, you do a little frequency stuff with it. That's beautiful. Part of the stuff that makes my voice work, though, is also the compressor. So I'm gonna have to try hard to actually get the compressor on the Rodecaster to do justice to my equipment. BTS 3 is still underway. BTS 3 is now on the back burner because the wood filled. We don't have any room anymore. So what I'm doing is I'm taking anyone who subs is going to be added to a list and then will be burnt up in a random order to the new board. But in order to accommodate this live edge board that I bought from Lydith, Pennsylvania, I had to drive way out into the boonies. Actually, Lydith is really nice, but we had to drive way out in order to find this thing. And so we got this board for hundreds of dollars. I'm going to cough. I'm going to go. Anyway, we bought this thing for hundreds of dollars, and now I need to use it. But in order to put it up there, well, I've got it up on the wall. But in order to get this thing burning, I needed to extend the y-axis. And so while I'm at it, I'm doing a lot of improvements. We're calling it Burn the Subs 2.5. Then we're going to get into software. So we're still working on Burn the Subs, and we'll probably do that on Tuesday. But yeah. Neural networks for voice recognition. No thanks. No thanks. There was somebody linked me to something that was like a neural network for your EQ processing, and I'm like, I don't like that. I don't like that. If you guys want to, I don't know, if I touch the button on this, will I reset all my settings? Yeah, there will be, I mean, yeah, there will be an initial stream where, like, if I click that, I don't think I'll have, I don't want to click that. I'm too afraid to click that. I'm not going to do that. Yeah, but there will be a stream where we basically just burn names onto the board. Okay, hold on. You know what I need to do here? This is what I need to do. Because I'm getting too distracted. All right, that's better. Got you, got you, got you, got you, got you. Bang, bang, you're dead. You're dead. Pretty much you're dead. You're dead. You're dead. That's where we are. Stream overlay. Probably pretty cool. I'm just doing. I don't have a chance to look at it right now because I'm fucking streaming. All right. Moving on. What's the next part? 33K from pin 1 to pin 6. Well, the problem is pin 1 is filling up pretty quickly here. So I think what I'm going to do is I'm going to move it out to here. So let's get a jumper on that. Let's do a little yumping. Maybe we could use blue. Let's not insult people watching my stream. Thank you very much. All right, let's see. I think the gray wires are a little longer, aren't they? I like this jumper kit is on its last legs. So that's pin 1, right? Oh no, that's pin 1. This one over here. This one over here is pin 1, and I'm just gonna bring it over here. Damn it! Come on. Wait, was it pin 1 and 6? It is. No. Yeah. Pin 1 and 6. That's like across the chip. The problem is I can't. 1, 2, 3, 4, 5, 6. Oh. Pin 6. Pin 5 is the one with a 33 kilo ohm that goes over to that. Yeah. 3, 4, 5. Oh no, I need to go all the way down here. Damn it! Screwed it up. Well, let's hope this will do that. Pin 5 is down here. Yeah, it looks a little sloppy now. It looks just a little bit sloppy. Nope, didn't test it. We'll find out later. I'm even wondering if I'm going to use the Zener. I think I have it in the final design. I don't know exactly what it's doing. I don't know where I got the idea to use it too. I don't have any of my notes or anything. I could probably look something up somewhere. I don't like these crossover lines like this. I'll pick that up a little bit and just do it like that, I guess. I suppose. I mean, I could move it out more if I just don't bend it. I could just go straight over. I can just go straight over. I gotta cross it anyway. I might as well do it like that. Actually, I could do this. Wait, I can come all the way to the top of this thing. Here. All the way to the top of this thing. Move this one down 1. That one down 1. This can move up 1. Fuck! Where did that go? It just fucking like jumped. Where did it go? It's in here. Okay, I found it. No, I didn't. No, I didn't. Like, that was ridiculous. Here it is. Jeez, this thing is jumpy today. There we go. That's going to clear up just a little bit of space so that I can get pin 1 out of here. The reason that I'm doing it so methodically is because I have a hangover, but also because I want it to be crystal clear where all this stuff is going, to keep it nice and neat for you guys and for me. I mean, you know, I benefit from this being super duper organized. No, I haven't bottled that yet. That's soon. That's soon. Those have calmed down with the bubbling, so it's about time. I'll do that. I'll do that soon. I haven't had time. I haven't had time for anything. So yeah, pin 1. That's not pin 1. Oh wait, it's not supposed to be. It's pin. Wait. No, it is supposed to be. It is pin 1. Hold on. Break it out. Break it out again. I put it in the wrong thing. Ah! Stupid thing. There's like a pair of tweezers that comes with some of these jumper kits, and those are like really good at placing the jumpers. These, unfortunately, these are like really good at surface mount stuff, but a lot of the stuff is like skipping out of the tweezers. No, you know, I tried to. I wanted to actually brew ginger ale. But apparently, like, they sell kits, but the kits just have, like, a concentrate. And it's like, why would I do that? I could just carbonate my own, like, seltzer water if I wanted to. That actually takes a lot of, CO2, so it's actually kind of wasteful. It's not cheaper than just to buy it. The suppliers charge a little bit of a premium on CO2, so unless you're bringing in like trucks of CO2. Oh, that was it. Actually, it was root beer. Yeah, root beer recipes that I'm able to find are like, yeah, then you add the concentrate. And I'm like, what? Like, wait, I actually want to like make root beer. Like I want to actually brew whatever roots, you know, put in all the flavors. But all the articles that I could find at the time were just like, why don't you just do it this way? Let's just get it from, just get concentrate and then brew it. It's so fun. And I'm like, this isn't brewing. Like, what is this? What is this? The other one, pins 6 and 7. Gets a feedback resistor. Come to think of it, there's a board where I could build both of these amplifiers that I have, where it takes the chip and then it's got all the amplifier stuff, like all the feedback resistor lines and stuff like that broken out, so that you can add surface mount resistors and you can build circuits like this. I don't like how proximity those are. I think if I flip the resistor, it'll be a little better. It'll be a little better. 5, 6, 7, like this. We're gonna try to finish this today. We'll see where we get to. I'm happy to stream a little later because I started later. We'll go into the evening. By the way, guys, if you're interested in space stuff, check out Cosmo Quest X. They're doing a hangout-a-thon, whatever the hell that is, this weekend. How many connections do I have on this thing? Not a lot. You know what? I'm moving this thing out. We're moving it out further. They're doing a hangout-a-thon, and I'm going to be a guest star on there, so that'll be neat. Okay, 100 microfarads from both of the outputs here. This output goes to what? It has a 33 kilo ohm resistor that goes to pin 6. So that's this. Son of a bitch. How many 33 kilo ohm resistors? You can't keep getting away with this. Yeah, I've got to move this one up. Unless I go down here and just come from there and go over. I guess I'll do that. Did I run out of 33Ks? I thought I got out exactly the number I needed. Maybe I counted them wrong. Unless one of these was a 100 kilo ohm. No, it's not. No, it's not. No, it's not. All right, I need one more 33. I didn't pull enough of them out. Am I sure about that? Absolutely not. Absolutely not. All right, let's just get another 33 then. Considered getting a soda stream at one point, then I saw how ridiculously priced the CO2 containers are. Yeah, they gotta like package it and everything, so they're gonna charge more for it. I thought CO2 was a lot cheaper. I used to have friends who would do paintball on their property, and they would buy tanks. They'd buy CO2 by the tank. That would have been great for brewing. I just buy the little serving bottles. I haven't really done any calculations on the cost, though. I'm sure I would not be pleased. Wait, we're already going to 5.6. This one's, 6.8. All right. I don't know where they came up with the system to put the K in there instead of a decimal place. It's a weird system. 100K. Why have we jumped to 100? Where the fuck is 33? Hold on a minute. Am I holding it? Is this it? This is 100. That's one hundo. It's Hondo. 4M7. 150. 220. Yeah, they're just getting larger. Hold on. Somewhere amid these. 80, 70, 60, 50, 39, 33. There it is. It was hiding. It was hiding from me. I had the first soda stream. Not sure if the flavoring stuff is improved, but it was gross. No, the solder is the ones up there are 100Ks. The 33s I kept over here. I probably need to reorganize all those resistors. All right, this is the 33. This is the last 33 going from pins. Well, you already got 6 and 7, so this one goes from pin 1 to pin 6, which is tough. It's tough to do. go up there and down and all the way back over. That's a really weird, this is a weird one, because like, well, if I'm already right here, I might as well just do that. So, all right, so we'll do one of these. I'll bend that right there, like that. It would be nicer if I could display it by having it up and around, but there's just not space for that. Uh, 5, 6, yeah. So right there. Is my head in the way? I think my head's in the way. Like that. And then this will pretty much immediately bend down. There we go. Bend the knee. All right, bend that, and then I'll clip these so that it fits nice and flat. And actually, this right here, this red wire, is our audio cut. That's where we're going to be able to sever the signal and add our EQ. It's kind of a big deal. Ah, I made it too long. No! No, it's all fucked up. Dang it. Alright, hold on. I'll fix it. I'll fix it. Oh, I see. There's like not room for the resistor in this. God damn it. You know what I'm gonna do? Let's straighten this freaking thing out. I'm just gonna drop it in and then jumper to it on both sides. No, you know what? No, I can make that work. I can make this 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 work. Blah, 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 blah. I can make this work. I can make this work. I can make this work. So from here, see, the problem is this resistor is like the size of the thing. Like I really need this to bend directly downwards, and it's just not. There, do that. There we go. That is super compact. Now I have room. I finally have room. Yes, this is an art form. Why would you ask? And then that. There, pin 6 to pin 1, which is a horrible jump around, but it's all I could manage to do while keeping my circuit clean. Pin 1, wow, pin 1, right like that. Nope, right like that. There we go. Pin 1 to pin 6. All right. Woo! Still working. Still working. What's up, Cybertrucker? All right. We're almost there. We're getting there. It's, you know, a little cerebral. I have hot ears according to the FLIR. That's hot in here. I got the fan on pretty heavy. I expected fall weather, but I was given midsummer. All right. Blip. So all we need to do is come out of pin 1 with this thing, and then we need to come out of pin 7 with this thing, and then we'll have to hook up a bunch of stuff to that. So we're going to need a pretty much like a clean area where we can build our transistor circuit. The entire point of the transistor circuit is to remove my voice from the power supply so it doesn't cause all kinds of issues. So I'm going to come in over here on 2 lines, and we'll just see how that shapes up. So first of all, I need a 100 microfarad on both of the outputs. One of them's coming from here. So the 100U, the negative side is connected to the side that has the stuff on it. So the negative with the stuff, like that. I guess I'll come over just 1 block. Although this is going to be the exit point for our EQ filter. Which, okay, so this part bugs me. This part bugs me, because if I'm to insert... Well, okay, never mind, actually. That's not the line that I wanted. No, it is. So here's the deal. Like, what's happening here? This line right here is one of my outputs. This line right here is the other one. So if I were to add the EQ, my theory is that I cut here and cut here. Or no, sorry. I cut there and this too. So basically, this is connected here, and then I cut this. Yeah, and that's where the EQ comes in. Yeah, that's what it is. So in order to add the EQ, what I need to do is basically just, swap these two, and then, yeah. Do you produce your own PCB? Who do you use? I'm using Seed Studio, because I know them, and I know their process and stuff. This circuit is the circuit that's on this board right here. We're modifying it to put an EQ in there. So right now, what I'm doing is on the perforated board, I'm building this whole circuit again. So, all right, I want to make sure that I can do a cut here. So I think what I want to do is rearrange this a little bit and make sure that it is cuttable. So I need to make sure that my pin 1, sorry, my 33 kilo ohm resistor goes to a trace. The pin 1 also goes to its feedback resistor. I think I did this. Wait a minute, I think I did it properly. Yeah, I think so. Yeah. I think I did it properly. Hold on. This would be the line where we could cut. And then this would have to be on the output. So what I'm going to do is I'm actually going to move that over to here. Move this over there. 1 pin over. That way, we now have... We'll put a little tiny micro jumper in there. And that will be our cuttable audio line, where we can insert the EQ filter. What it does is it separates the 2 op amps, and it allows me to take that signal and route it around. And then I have it organized as output and input. Just like that. So now on the input line, we go to the 100 microfarad. Too bad I can't move it up this way, huh? We have it going this way. Well, maybe I'll just do this. Negative is facing, other way around. I have it going like this, and then I have a 100 ohm resistor. That actually we do need to work it out so that I can plug in the transistor circuit on this. Oh god, this is gonna be a nightmare. Let me see, 100 ohm. It's Halloween on a Wednesday this year. I'm hoping it is, because I never prepare. Everybody like, I love Halloween, I really do. My birthday is ridiculously close to Halloween. Actually, yeah. And I always said, no Halloween birthdays to my parents. It's Sunday? Oh, thank fuck. So I don't have to do anything. All the content creators love doing big extravagant things for Halloween, and I never remember. I'm really bad at that. Oh, I'm looking for 100. 100. 150, 82. Son of a bitch. Stupid fucking... I don't have any 100 ohms. Nightmare related to 3 mirrors. You did it. You did it. You cracked the code. I can do 150 or I can do 82. I don't know what happened to 100. Did it get misplaced? Son of a bitch. What is this one? Unlabeled. Pen M. That's out of the question. Scarier games. I don't know. Smaller values that I can solder together. It's only a 100 ohm resistor. Maybe put 10 of these. 247 ohm resistors. I could put surface mount resistors in there, but come on. That's silly. 68, 75, 82. This will probably just affect the gain on the output. Let's put 120s in there, and I'll just have to turn the volume knob up a little bit. As long as they're balanced. They're both on the XLRs, so 120 versus 100 is not that big of a deal, I don't think. I hope not. I hope not anyway. That's annoying, though. So we got to remember that. Let me note that down. Write that down. Write that down. Just make sure they didn't get misplaced somewhere. I have a 4 ohm, 2.2 ohm resistor. What the hell? What is this? 1R. If only I had 100. Close enough. Close enough. Horseshoes, hand grenades, etc. Etc. So this one can go directly like this, because I'm just jumping it over to the next jump. The next yump. And there's going to be a lot of stuff connected to this next piece, so I need to just do one of these. Come on. There we go. So there's that. So that gives us our first connection. But if we were to power this up, we would have a really bad time. There's 120. 120, 120. So it's going to go 120 through the 100K. I hope it doesn't affect this too bad. And then this is a Zener diode. So, all right, continuing on. Where do we go now? Where do we go now? 7. Pin 7. Also has that 33 kilo ohm resistor on it. And I'm hoping, I think we need to remove pin, we need to move pin 7 all the way out here. I think that's what needs to happen here, because I need space to work, and we need a lot of connections on these lines. I need space to work. What's this? Holy shit. I can actually come... No. I gotta think of a clean way to do this, chat. I don't know if there's a clean way to do this. If I go from... What's that? 5, 6, 7. Right? And then I go out and around and down and over. I'm still gonna get in the way of all the stuff that I want to be doing. Unless I, like directly is not a great way. Unless I jump over to here and do the circuit over here. Maybe, but if I go down, out, and around. Man, digital electronics is so much easier than this stuff. Because we still have to build that whole transistor circuit around this thing, which is going to get in the way of everything. That's a long damn path for my audio to be taking. Let's get an orange jumper over here. Let's get the orange jumper on. I don't know if that little circuit board that lets you There's like a surface mount prototyping board that lets you build op-amp circuits, right? I was thinking maybe that would be a good thing to use for this, because then I could build like a. Hold on, let me just humor. I'm gonna humor myself on that front real quick. Yeah, I'm not gonna do a potentiometer. Yeah, these things. Hold on. Take a look. These are boards that I like rarely ever use. So these are like surface mount to breadboard devices or boards. You can get these pretty cheap now. They used to be very expensive. But some of these are specifically built to allow you to use op amps and stuff. Oh boy. This one's for a quad. There's nothing underneath. How would that work? Because one's set up as a feedback, I think. Oh god, there's even like a little picture of the stuff. No, that might not be too useful to me. That's a hell of a board, though. Would simulations be useful for tweaking resistors in audio application? Probably. But I mean, if you're tweaking resistors, you should do it on like the final thing, because it's all about how it sounds, right? Will that switch from 100 to 120 ohms affect the reverse bias of the Zener? No. The Zener's not really involved in this, but it will affect what's going into these transistors over here and what's coming out of the end. I don't know. I don't really think it's going to do all that much. But I mean, yeah, if you're going to simulate something, that means you got to put it together, and so I don't know. Yeah, they're good for like scientists and stuff, right? We got to put together like little circuits and things. But yeah, I like using them for surface mount prototyping. I don't think this will be too useful. I don't think this would be too useful. Although there are the go-betweens between the what is that? That's between there and there. Oh, that's positive and negative rail. Okay, never mind. That's the decoupling capacitor. But there are like provisions for feedbacks and stuff. And I guess you could run jumpers underneath it if you need to. Well, that might be, this thing might have simplified it a little bit, and then I could have used all surface mount stuff, but it would have been a little bit more esoteric. And you guys might not have known what was going on. Ugh, my head hurts just looking at that. All right. Remember, no stream tomorrow, but on Sunday, I'm going to be hanging out at the Hangout-a-thon with Cosmo Questix. You guys can catch me on that show. I will be talking about space stuff, believe it or not. I don't really know a whole hell of a lot about space stuff, to be honest. I don't know how much I really know about space stuff. But, yeah, we'll have fun with it. All right, so we're trying to get pin 7 out of here. And I'm just trying to not, like, make a total hash of this entire board, you know? I'm trying to actually, like, make it look like something that I can use. But if I come out of pin 7, 5, 6, 7, right here. Come out of pin 7, I can move. I mean, I could use this part of the board, too. I'm trying to keep it in the column just because it's a little bit more, it's a little bit more like what you guys would potentially be doing, right? Oh, my dip chip's back. I mean, this could have been a dip chip, but it's not. I love surface mount. I don't know why. People are stuck in the past. I mean, prototyping like this is like, you know, is key. But I guess what I can do is just move around. I'm trying to keep these like spaced out from everyone so that I can properly put together all my paths. You know what? No, we can do a small jumper over to here, and then I can put the 100, and then I can put the capacitor. Yeah, that's okay. All right, we'll do that. We'll do a small jump because I don't really need access to this part, but I am going to need, well, I am going to need it to be on an unfettered. After the 100 ohm resistor, I need plenty of space to plug stuff in. So that's what this is. Because I need 2 things to plug in here. I'll need 2 things to plug in here. So let's do a 100 ohm resistor across like that. and I'll move this up. And then I can take them down to this part where I can build the transistor circuit. All right, we got a plan. We got a plan, chat. We got a plan. I have a plan. If only I could find the jumpers for it. I know my decisions have like changed on the fly several times within the same sentence. I know that's tough to follow, you guys, but you know, I need to come up with the ideas somehow. That just doesn't work. I need a shorter one. It's like that thing that people do on the internet where they're like, aha, you're a hypocrite. You said this thing 6 months ago. Bother, why did you change your plans? I thought you did it this way. I'm lucky I don't get a lot of that. Red Letter Media gets a lot of that. A lot of that. Like a lot of that. So if I do this, and then I have to go through a capacitor. I don't want to block these, though. Damn it! Maybe I do have to change the plans. I think I have to change my plans again. No! I need to be, like, here. Yeah, alright. Fuck it. God damn it. I felt so good about that result. But it just didn't work. Well, we'll just cross like this, and then I'll go down and around, and back over like this. I hate it, but I'm gonna do it. This one is our nearly 100 ohm. That one goes not directly to this wire yet. It goes to here. And this can get short. Get short! Like that. I move it up one. Okay, so that's the output from the op amp. Comes out, down, and around. That's, nope, 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 nope. The problem is I'm trying not to cross this junction right here, because this is where I'm gonna get this is where I'm gonna cut audio and insert the EQ. So I'm trying to keep it away, but it's crossing over kind of a vital line right here where I'm gonna put that big transistor circuit. That big transistor circuit's gonna be right here. So it's like, how do I route this so that this isn't getting in the way? And I can't. The answer is I can't, unless I went down around it. No, see, it's all too sloppy. It's all too sloppy, all of it. So I'm just gonna have to have that there, and then I'll have to sneak the connections under it. I always wonder why these leads are so long. It's just what came in the kit. The kit that I have is like monstrously long, slightly monstrously long, orange length, and then it jumps down into the much smaller lengths. Yeah, parallax is very, parallax is something that we mention a lot here. When you're looking at pins on pin headers and trying to figure out what rows they're in, parallax will mess with you 10 times out of 10. Oh, the leads on the resistors, caps, etc. I guess because they don't know what application you're doing with them. They don't know what you're doing with it in the end, you know? They don't really know what you're going to do with this stuff. So they give you plenty of leeway. All right, so we got the 10U. We got the remaining 100 kilo ohm resistors. I didn't get the 470 yet. And then we've got our two transistors. So our transistors are 3904s. Maybe they just don't know the thickness of the thing you're installing them in, too. 3904s. Now, I feel like transistors were specifically engineered to confuse the ever-loving shit out of engineers. Base emitter collector, at least they give you a three-dimensional drawing like this. You didn't used to get a three-dimensional drawing. You would get that D-shape thing, right? And they would just be like, good luck! So base emitter and collector, we got to figure out how we're going to hook these up to one another to produce this circuit here. Bases on the outside, collectors together, emitters to their individual places. Start your engines. Oh, and those are connected together too. So we're going to need separate the emitters, sorry, the collectors, separate the collectors. So pin 3, the pin facing down there, is separate, and the other two are bussed together. Okay, I think I can work with that. I don't know if I can make that very clean, but basically we do 1, 2, 3 like this, and then I'll do 1, 2, and then space 3 out. 1, 2, and 3 goes way the fuck over there. Just like that. And now I've got my 2 connections. And those go directly to the line. Oh boy, what distance is that? You know what? Rip it all out! I'll jump down first. I'll go first. Are those 100Ks connected to the same thing? Technically they are. That's interesting. So the two 100Ks are jumping down to the same pin. Interesting. See, I'll use this one. It's a little far away, but I think it'll be okay. Use that one. Let me find another one of them. Watch, I use like the only one that I had of that, because that one looks a little different from the others. It looks like a slightly different jumper. I think that was the only one that I had like that. No, it's just one that looks a little manky, that's all. Oh no, this needs to go to the same pin, so it actually has to be shorter. Shorterlier. Wait a minute. No. It goes one pin below the other one. I got it. I'm smart. I can do thing. I do thing good. I do thing on internet. I'm gonna move these down one. I don't recognize that number. Is it my car warranty? What's the over under? Do we think it's car warranty or hello? Thank you for calling. Please record a message after the beep.
How are you doing today? Glad to hear it. At GBC Business Group, we handle your company's incoming and outgoing customer calls at a very cheap rate. These phone calls include sales, customer service calls, order taking, or
It started out by being like, "Hi, how are you doing? That's great to hear."
So if you're interested in getting one of these services,
Okay, anyway. I hope they record that. Looks like you have a couple rows freeze between the chip and the white output. So jumper 1 to the cap and the resistor to the blue, or would that be too messy? Maybe. A couple free rows between the chip and the output. Yeah, I did that purposely. I don't really want to use, I don't know, I want to spread out, right? So I'm going straight down to here, and then I'll do the 2 transistors here. Now that robot will think I'm murdered. Good. Good. It deserves that. Good. Yes. Jedi. Yeah, the 2 100s are going to go down to one of the pins down here. So it's going to be doop doop. And then we've got 2 lines coming in here. So I'm moving these down 1 so that the red wire can properly bridge them. Yeah, that's going to lay a little bit flatter now. Ah! This needs to be 1 row below. 1 row blue. Row blue, blue. Like that. And then these have a lot of connections, so I don't know if I need to break out any of the lines on them. But like that. And then like this. And now my collector and emitters are both connected to one another. I probably need to do this to get a line out of here. Out of here. This is a busy circuit. It looks like the emitters connect to positive. So the emitters connect to this guy right here is just boop, boop, boop. So that's connected to positive. which means, son of a bitch, I hooked them up backwards. That's right. It's the bases that are, the bases are the middle pin. Ah, come on, man. Oh, it's the, okay, so the emitter, oops, the emitter, which is the bottom one. Hold on. Pin 1, emitter. Those are connected to one another, and positive. Okay. Bases. That's not the circuit. Bases. So many skipping, so many references. Bases is connected to the pins. Damn it. Oh, but through the 100 kiloohms and each other. So yeah, okay. I'm still good. I did it right. I didn't flip it around. The collectors are what's connected to the outputs, and the 100Ks go to the bases, which is the next pin. So the next pin on the thing is connected to the 100s. Is it raining out? It might be. I have the fan on pretty high today, and the temperature suddenly dropped. It's so nice to actually see Nightbot like doing the lines correctly, because for the longest time this has been how I see you guys, and so you can see that it's all over the fucking place, right? And I was rest assured by you people that the Nightbot, the equal signs weren't making the messages all stupid looking. We put a lot of Octogen, and I put a lot of work into making that look good. They never fit the width on any of my screens. Gonad, you are surrounded by what is ostensibly a ticker tape monitor. Width of your, don't tell me about the width of your screen. Your screen is off the charts in terms of width. If you guys don't know, Flatulent Gonad does stream, and you guys should watch his streams. They're a load of fun. If you're into that sort of thing. If you're into fun, which I'm not going to judge. I won't judge. All right, so these are the two last 100Ks that I got to put in here, and I have to get them to the bases of these transistors, and I've only got so many holes left in me. That's actually not going to work out. So what I'll do is jump those over to somewhere else, I suppose. It just sucks because I guess I could move both of these down here, and then I'd have access to positive and ground. Yeah, that might be better. I'm just going to spread out a little bit, and then I'll do jumpers across. Fun! Ugh! Fuck that. I'm here to watch breadboarding. Yeah! This looks like it's not fun at all. I'm in. This is the best. Welcome to the chat room. Wait, what happened? ultra wide. Yeah, that's his existence. Yeah, so what I'm doing is I'm just busting these up too. Oh god, the wire on that thing is so fragile. I wonder how the janky breadboard is going to affect everything. I actually need 4. I need 4 of these. Oh boy. Oh boy. Here I go. Well, I already see 2 of them, so I really need to get another one of these kits. I need to get another one of these kits. This thing has been through hell and back. The fact that it came back is even weirder. Went all the way to the netherworld. Dear God. What have I done? Yeah, these are actually a touch shorter, but you can kind of bend them out. All right, those are all the connections to the transistors over there. So the one that goes to ground is... Wait, why does that one have a 10U on it? Oh, they both do. Okay. So the 2 bases go through the 10U to ground. The bases are in the middle. Here's the 10U. This is just snubbing a little bit of DC on the line. So 10U here. Of course it's right at the gap. Of course. It's always at the gap. Whenever I have to go down to ground, it's always right there. God damn it. Why does it always do that? It's so annoying. It's like right in the middle too. I guess like that'll kind of work. Okay, so there's the capacitor to the bases. I changed chat font size. That may be why the lines don't fit. Yeah. In order to put together the overlay, I had to turn Chatterino into super old man mode, and I kind of like it. Like I kind of can read this a lot more easily when streaming. I had to do a little bit of work to get the width right so that the Nightbot messages would come through properly. We got the 120s in there. We got this hooked up. We have these two connected. We don't have this. I have the 10U to ground. I didn't get a 470 out yet. That's on the same line. Man, those bases connect to a lot of things, don't they? Can we get that in there? Yeah, I think we can. I have to move this over. It'll be the last thing that we can add on this side. So we'll do that. Those will be right up against one another, which I don't really like. But I'll have the 470 ohm. Is that K or is... Yeah, it's 470K. Let's get the 470K out and let's get that installed. It's, you know, piece by piece, you put these circuits together. That's how it works with these things. It takes a little bit of effort, but if you keep organized, you can move through it and hopefully get things pretty organized. Now, sometimes that's 47. Where's 470? Sometimes it helps to stop in your tracks and just redo everything. Just redo the whole thing. If you really want, because if you're going to be working with a circuit for any significant amount of time, it's kind of crucial that you have a very organized and clean layout for all the stuff. Yeah, stop collaborating and listen. Put your hammer pants on. It's good. It's important to be comfortable while working with circuits. Hammer pants, check. Or is that Vanilla Ice? I don't know. It's all that era. It's all that same era. Garbage. It's all garbage. We do not need a lot of leads coming off of this thing. I'll just do this and see if it works. Boop. That's actually kind of short. Uh-oh. Uh-oh. Did I fuck myself? No, I did not. Okay, that's still good. Still good, still good. It's nice and compact. Keep it tight. Keep it tight. There you go. There's that one. I know it. 100 micro goes from the emitters to positive. Well, the 100 micro goes basically from positive to negative on the whole thing. That's interesting. How do I do that? I don't even know where my freaking positive is. I mean, if 100U goes from positive to negative, I can just throw that on. Like here. Like it doesn't even need to be here. Like I can just put it right there. Where'd that 100U go? Did I have it? Yeah, this one's 100. Nope, this one's 47. What's that even doing out? Is this one 10? That one looks like a 10. Yeah, that's a 10. 100, 100, 100, 10, 10. Did I miscount? I think I miscounted. Where was the other hundreds? 100, 100, 100. No, I should have 3. What's going on over there that I put 100? Oh, 1, 2, hold on. I'm trying to get my... Did I really need 4? Yeah, I forgot this one down here. Okay, so let me get another one. Easy to find. Easy to find. Easy clap. 3.3. 47. 100, but that's 50 volts. I don't need that big of a cap. I don't think it would harm it if I just used 50 volts, but that's 47. 220. 470. Oh, please tell me I actually have another 100 in here. I think I do. I don't think there would be any reason that I didn't. I don't think there would be any reason that I didn't. 220. I feel betrayed by my own capacitors. How big are they? Not big. Okay. Gotta remind myself of what they look like. I've been looking at capacitors too long, chat. I'm starting to lose myself. Well, this is 100. It looks fancy. It's like a fancy 100. It's also 50 volts. I think some of these caps came from like a kit that a friend bought me in order to fix his monitor. I don't know if any of you remember that. That was a long time ago. Are what are they? The silver or the gold ones you're saying are audio grade? I didn't use audio grade in my mic pack that I'm using right now. As long as you tune it out. You can tune your way around dumb caps. Oh, Nichion? Nichion? I don't know how to say that word. I always like to put up a fight against stuff like that. There's a lot of snake oil in audio, and it's good to get around it. God damn it. Am I unable to find this cap? Things were going so well. Now I just can't do it. Fuck, that might have been... I can't do it. I just can't. All right, where the hell is this? Like, there has to be another one in here. I mean, I guess I could use one of the 50 volt ones. I guess. $47. At this point, I would start putting them in a different bin as I checked them so that I could make sure that I'm looking at every single one. This is the problem with miscellaneous bins instead of a brutal organization. I mean, I guess I could use one of the gold ones, I suppose. What are you? 220. Oh my god. Damn it. Alright. It's like, just I can't find it. I don't know. Maybe I used them all. It's really kind of feeling like I did. $470. This one's 100, but it's 50 volts. I would very much like not to have the giant capacitors all over my circuit, you know? Now keep in mind I have all this stuff in surface mount, and it's way more organized, and it's just better. but here we are in through-hole land. My through-hole electronics collection is fairly miscellaneous. It's just not as organized. 470. Damn it. I think the gold one was a lot nicer. See, that's 10 volts. That thing would blow up. Possibly. They're just, yeah, it's just not, this is nothing. Alright. Well, we use the big one. This one is going between power and ground anyway, so I guess it's just a little bit of a... It's a little bit of a suppression. It'll I don't know. It'll change the phase of any AC on that line, on the power and ground lines. Ta-da! That's all I had to do with it. I really hope it doesn't explode. I don't think it will. This is 50 volts. Phantom power is like 40. Boy, I hope nothing explodes on this fucking board. Well, Phantom doesn't have a lot of current behind it anyway. All right. 2 100 kilo ohm resistors, and then I think we are good to go. So these go from each of these channels, and they go to each of these inputs? No, they both go to this guy. They both go right here. So we could just plot that out. Use this thing because it's a big distance. Well, at least that one is. Oops, that's not centered. Hold on. Just like that. That. I gotta make sure that this goes back to the right spot, which is one above the other one. Sure all that's stable. And this goes to the second pin, which is the base. The base in your face. That one I'm gonna have to sneak in up here and come down to there. Track the base. It was in your face. All right. All right. All right. All right. Damn it. The tweezers are like ejecting stuff everywhere. Tantalum electrolytics give you 0 leeway when it comes to overvolting. Well, we'll have to watch the thermal cam to make sure we don't end up on live stream fails again. Although it's really actually a good decision. It's a good business decision to end up on live stream fails. Let's be fair. Let's not lie. Let's not lie to the audience here. Yeah, ending up on live stream fails would be awesome, but I'm never gonna force an error. I don't think, no, these are just like electrolytics. I don't think they're tantalums. I don't know what they got in them. Do a nip slip. No. Problem is I'm small enough that I don't get a slap on the wrist like other streamers. If I did something to get me banned, I would remain banned because I'm not cool enough. I'm not cool enough in the eyes of Twitch. I didn't even make the list of the leak. All right, final detail. Zener diode between positive and negative. And I'm just going to verify that that's what we got. That's not even soldered. Hold on, that's not actually soldered. It's actually lifting up off of the pad. Hold on. Just gotta do a little surgery here. A little bit of diode surgery. I don't think I can get this far enough down. We'll have to go over here. There. A little diode surgery. Now here's the trick with breadboarding a circuit like this. The next step is to actually check over everything. Because I'm going to be plugging this into a couple $100 of microphone, and I really don't want to fuck it up. I really don't want to break my microphone today. You know? I think you guys can hopefully understand that a little bit. Okay, what is happening over here? First off, that wasn't plugged in all the way, so it was wiggling all over the place. Stab it. I need that to bridge contact so that surface tension holds them down. There's nothing going on Twitch? Oh no. Oh no. I'm still not streaming late. I'm actually just, it's usually my stopping time in like a half an hour. It's just lately the projects have been throwing me for loops. They've been throwing me for loops. They've been like running out of content at 4:30 instead of 5. That's just what happens here. And so if I'm not gonna draw out a stream doing nothing, you know? Pseudo memes. Thank you for following. Grep memes. Pseudo grep memes. -L. -sus. Pad the intro like tomato. Where he just lies about not liking something a little bit controversial. Rabaz does that too. He'll talk about COVID or some shit and then everybody's up in arms. I don't like doing that. I don't like doing that. I do allow it to be a little bit like organic, flowing into from the stream intro to the regular intro. I usually like to keep that fun. That's why I've been here. None of my favorite streamers are on. Well, thank you. It's nice to be at the bottom of your list. I appreciate that. Anyway, we got to check over the circuit. We got to check over all the stuff. Make sure I got it all right. Listen, I'm even in the boat where I don't want to keep checking this shit over because I'm sick of it. I want to plug it in and I want it to work and then I want to go to bed. But I want to eat some food is what I want to do. But yeah, I feel like we need just a once over on this thing. So I'm going to run through this a little bit. Probably just an idiot, but did you actually change anything with Zener? So what the Zener diode is doing is it's snubbing, well, any little things that are sort of on that power line, and it's going to keep it at 10 volts. You could do a resistor to ground to bleed off the extra current and take it down to 10 volts. But I decided not to do that, and I put a Zener diode in there instead, right? That's essentially the plan here. And what these two are supposed to do is these are actually deleting your audio from the power line. They're removing your audio from the power line in some way, shape, or form. So the Zener is in there just to kind of stabilize everything. In before 15-volt Zener. I actually don't know what the Zener diode is because of all the labeling mishap, but I think it's okay. I don't know where I got that from. I think I got that from something else. See, that guy's pointing at it. Yeah, this is essentially what the circuit is. I should read this later. This is actually fairly interesting. If somebody can actually explain it properly. 48 volts, the sound impedance of 3.4 kilo ohms. Voltage Q1, Q2 collectors strongly dependent on the load current. The circuit will work as intended, proving the load somewhere around 10 milliamps. Coincidentally, 10 milliamps is a good current for low noise JFET. TL702's noise contribution, huh? You and Andy, correct. Zener's alternate way to provide voltage stabilization. Though when you come to measure the resulting circuit's performance, you may find, as I did in similar circumstances, that it is a dual role as a noise generator is difficult to overlook. Note that Zeners around the 10 to 12 volt range and higher are technically avalanche diodes and quite noisy. Well, that's what I got. So when you were soldering, oh yeah, it's okay. So parallax, right? We talk about parallax a lot. All right, hold on, let me. Okay, I'm ready. We talk about parallax a lot on the stream. Parallax affects when we're doing like a rapid breadboarding kind of thing. But it also affects like when we're soldering. And so what happened was that Zener diode, I don't have if I had a soda can here, that would be like the same exact shape as the Zener diode. It's too bad. You could just think of the Zener diode as this wire stripper. And so we were looking at it from straight on above. And when I soldered it, what happens with surface mount devices is that blob of solder has surface tension on it. And so what ends up happening, if you don't have anything holding this side of the chip and you've got a blob over here, technically surface tension causes it to do what's called tombstoning, which is lifting up vertically like a tombstone. And we've actually in old audio stuff that I used to do with a company in Westchester, a guy made an adapter and he called it his graveyard adapter. It was all tombstone surface mount resistors and then little wires going up to the tops of them. It was pretty cool looking. But anyway, so what happened when I soldered that Zener diode is that surface tension made it sit like this. And so when we were viewing it straight down, it didn't look like anything was different, except you couldn't see the solder sort of do the surface tension flow up to the one side of the chip. So when I looked at it with Mark I eyeballs in meat space, I was able to see that it actually had lifted one of the contacts. So we looked at it again, and this time I got the solder to kind of blob on both ends. Technically, you shouldn't have a blob of solder on both ends, but if we're rapid prototyping something, I'm not going to care that much about that. Okay, so the Zener diode is in there. It's kosher, so we can put that in. I just wanted to verify that the Zener diode was a good idea. So I'm going to put it all the way out here so it can explode and not hurt anything. So I suppose the next step, I'm not going to check over the circuit. I said I wouldn't force any errors, but I think not checking over the circuit is something that I should do. I feel as if not checking the circuit is something that I should do here. Let's see. Microphone comes in, goes to there, up, positive. Capacitor there, no connection to negative. Negative of that, negative of that. Those are all on there. I think we're ready to go, chat. I'm going to plug my XLR with 48 volt phantom power into there. I won't plug the lavalier in. We'll check back in once I do it. There we go. What the hell? What happened? You guys heard a shit ton of static. Everything just stabilized now. Hey, the audio level didn't drop out. That was weird. What did you guys hear? Just scratching. Why would it be so scratchy? Who would have scratched you like that, circuit? We could have all kinds of stuff happening in this. I'm probably just going to have to check over the entire thing. Nothing got hot. That's always good. Yeah, that's the weird part, is that it kept doing it. All right, hold on. We're going to do it again. This time I'm going to mute when I unplug and plug. All right, so that was weird. Hopefully I sound the same. All right. Did I get the pins right for... Let's check the pins of the electret. Yeah, let's check the pins of the electret. Scratchy? Check 1, 2. I don't know. The static is like it not coming up properly. I don't know what that is. Because like unplugging and plugging it in, still noisy. I hope that's not permanent. Check, 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 check. Hello, hello. Hello, and welcome to Movie Phone. No, those are the right pins. Top left, lower, yeah. Those are the right pins. What happened to you? Yeah, this should be the right circuit. Took a bit, then the noise disappears. Seems like, yeah, the circuit needs to, like, figure itself out a little bit. I wonder what that is. I have to do more analysis on this thing in order to find that noise. The scratchiness. That or just poke the circuit until something happens. Tiny bit of noise when you first put it in. I thought that was the best part. Anyway. I mean, I guess I could put the Zener somewhere else. I don't know. I think it'll be just as effective. Is it in correctly? Yeah. So okay, so what's happening is we didn't get any audio. We didn't get any sound out of this thing. And I guess my candidates are... Is my capacitor in backwards? No. Negative is facing the rest of the circuit. That's here. That goes to a 100K to ground, and then that also goes into pin 3. Yep, that's all there. That's all there. That's there, that's there, that's there. The 100K also goes to ground. Oh, wait a minute. Hello. Well, look at this. Well, look at this. Look at what's going on here. Chat, look at what's happening. Oh no, never mind. Never mind. Nope, never mind. I thought I wired that to negative and the other one to positive. I thought I flipped my negatives and positives. So we got a 100K going to positive. Actually, should that one be going to positive? What is that one? That's 33 to positive. That one comes over there. We can't see it, but it goes under here. To pin 3. Wait, what resistor goes over there and then goes to pin 3? Hold on. Oh yeah, because that's the virtual ground. I had to bust it out to two things. I don't think there are any errors in this circuit, but I will have to look when I feel a little better about checking over the circuit. I have to take a break. This is where you take a break and then you figure out what happened to your circuit. It's interesting that the cut is so complete. We've just got literally nothing coming out. And I made sure that those are the right pins. The 100N Cappy guy. C5. That's the decoupling capacitor for the chip. So yeah, that's right in line with the power pin. And then it goes to... It goes to ground. Yeah, taking a break and then looking at it is probably the best strategy. I mean, we did just find that, so let me just correct that real quick. How is that? How is this wired? Ugh. Never the right length. TWSS. Okay. Positive and negative there. And then pin 8, the ground. Good. Good. Yeah, I think, you know, other than that, I don't think there are any mistakes, because I don't actually make mistakes. I'm not capable of doing that. Is it actually connected? That's a little dodgy, but I think it is connected. Yeah, that's got a connection. That's got a connection, I believe. I believe. Nothing exploded. That's always nice. Bottom one goes nowhere. Oh, yeah. Oh, yeah. The bottom one. The emitters that go to power. Hello. I told you, I don't make mistakes. I'm just doing this to test you. This is for your benefit, chat. Where else does that? That one has the... Hold on, wait. Ah, throat's dry. Hold on. I got like a sudden, very extreme dry throat. Hold on, let me just get my... Let me get my voice back. Wow, that was like a sudden onset dry vocal cord. In the space of 2 seconds, my vocal cord went from a slip and slide to a dry lake bed. We could see the cough through camera vibrations. That was a hard cough. Because it was like, at first, it was just like a little dryness, and then I coughed, and it was just like, vocal cords are taking a vacation. Damn. Okay. So I got the 10U to the bases. The emitters are both going to positive. Let's check it out. Now the bottom pin is, hold on, bottom pin. I hate all the referencing that I got to do. But the bottom pin is, this is what happens when you get tired, by the way. Pin 3, that would be the collectors. Wait. No, we're talking about the bottom pin. Shit. Did I wire the transistors backwards? Is that what happened? Damn it, none of these are what I'm looking... Okay. Let me check my work again. So pin 1 is the emitter. Okay, I think I have the transistors in backwards. Yeah. So I actually want the collectors, which is pin... No. Wait, yeah, pin 3. Yeah, I want to flip them around. And I want to de-extend this pin. So 1, 2. And then flip this thing out like this. That's hard to do. This one just straight up flips. So now, bases are in the same place. The track's the base. The Kubla's in the place. Is that what the name is? It's some weird name. Okay, so now those are there. And then these are both the emitters. Pin 1, yep, on that side. God, that's so confusing. But both of the emitters, the ones with the arrows on them, in our circuit, both of the emitters, I need more monitors for this. Both of the emitters, the ones with the arrows on it, connect to positive. Let's do that. Connect to positive, yeah. Connect to positive. Both the emitters, blah, blah, blah. So we got to take this to there. Dun, dun, dun. This is why I like designing circuit boards more, because you don't make these mistakes. Because everything's in CAD. Sometimes you got to work with your hands. You got to work with your hands. You got to make it work. You got to do the work. All right. Those are both plugged into the same one. Yeah, they're supposed to be. Yeah, both 100Ks are plugged into the bases, which is the center pin. And then the two that are separated go up to their individual output lines there. Okay. I think we're ready to try again. It's weird that there was no audio instead of just like broken audio. But all right, I'm gonna mute. All right, so yeah, it didn't really work. The transistors weren't failing. They were just getting a little warm. They're just doing their job. Those are connected to positive, and that's it, right? Yeah, positive, and that's it. There's also 470K to ground. Wait a minute. No, that's not the bases. Yeah, the bases are connected to the two 100Ks to each audio line. And then they also go through a 10U, which is here, and a 470 to ground. Yeah, it is weird that there's no, like, nothing. It's weird that there is just, like, nothing. Are the caps in the right direction? Yeah. I wonder. Yeah, is audio getting through them? I don't know. I do not know. That goes there, and then output. Yeah. And actually, the way we had it before was exactly how it is in the schematics, so I'm going to put that back. Because we know that wasn't it. Let's see. Yeah, the pop when I took out the cap, but that was, yeah, that's just capacitors being capacitors. Huh, I wonder what's up. I wonder what's up. Why do you do nothing when I put so much work into you? I deserve for this to actually work. Is the Zener diode shitty? Did I take the Zener diode out? Did I try that? That means the voltage is going to fluctuate a little bit on this thing, on the output, or on the power lines. That is definitely ground, pin 4. I mean, I checked the transistor pin out, but yeah, I could look at the scope too. I could start plugging things with the scope in order to see where they go. I'm hoping for like a big glaring error somewhere in this. Like I misinterpreted power and ground somewhere, but it doesn't really look like it did. Doesn't really look like it did. Why do you forsake me? What have I done? No. Let's see. I'm just looking around. I'm just looking around right now. And I see things that I recognize. Let me see. What direction is that cap supposed to be in for the input from the lav mic? Positive is supposed to be going towards the mic, which it is. Damn it. I was hoping that would be wrong. I mean, my plus and my minus for the lav, I did the red and the black wire just as it was in the thing. Let's hold on. Let me do a double check on the positive and the negative for the lav. Positive and the negative for the lav. If I can see some stuff that I recognize in it, then I can check it out. Well, the Zener is clamping to give us 10 volts. All right, so the negative line of the lav is towards me on the board. So we got to check the board real quick. And we are definitely on the right pins, right? Ha. No, wait, no, we're over here. Oh, we are on the right pins. Okay. Shit. Darn, I was hoping we wouldn't be on the right pins. We're definitely on the right ones. Okay, I'm gonna put this back together before I ruin it. What could it be? What could be wrong? Hold on. Put the screw back in without stripping out the thing. Come on, man. Cooperate with me a little bit here. Click. Ooh, jeez. That took a bit to click. What I'm doing is reversing the screw until you feel a little click over. And then, you know that you're in the previously dug threads. You can get that pretty tight. There you go. All right, so negative towards me on the board. Last time I had that board, I kind of threw it. There it is. Just make sure that I can get to it again. Yeah, that's correct. Positives there, negatives there. And that's ground. Okay. Yeah, those are the correct way. But this one worked really well, this circuit. And I used curved traces to get everything together. I don't understand why this one doesn't work at all. At all. Now, the next step for this is going to be taking a multimeter to this and checking it all over just to be sure, because I don't think there were no glaring errors in any of the stuff that I did. No glaring errors. Once I got some of these pins wrong. That goes to the ground. That one does the loop. That goes there. And then that one is coming back in on the other side. Where's my feedback? Oh, this is it. That's the feedback. So my audio should be coming in here, going around here. This is where it gets its power from. And this is the current, whatever, limiting resistor. Whoop. Over to there. We go into... Could I have gotten my pluses and minuses wrong? I don't think I did. I don't think I got my pluses and my minuses wrong. That's a Gmart emote. Hey, cool. I like axolotls. They're cool. Hey, useless pony. Oh, this is the wrong view. What the hell is this view? I'm scared. Okay, sorry. Here, we're back. All right. Everything that I've done here appears to be correct in my mind. However, I'm probably going to have to wipe this schematic when I feel like it and come back and do all of the same stuff while rooting through my circuit. It's not exciting. It's not fun to watch. It's not fun to watch. I would have liked to get a positive. I mean, but this is what we do here, right? We're not playing video games. Video games are designed to allow you to overcome these issues with a little bit of struggle, and then you get your nice dopamine positive reinforcement ending. Electronics aren't like that. Physics don't care about your feelings, right? So in spite of my frustration, getting more frustrated is going to do absolutely nothing for me, and continuing on with this and trying to weed out the problems is going to require actual work. So I am going to probably wrap it up here. We didn't really even go that late today. We're like 20 minutes over. It's ridiculous. CAD packages are not video games either. Please tell my coworkers. Dude, this is as close to a video game as you can get while doing actual work. This thing was fun as hell to put together. I'm super excited. This is literally exactly what you guys are looking at the top of the breadboard. How cool is that? And I know all the dimensions and everything too. It's like cheating at video games. CAD is like cheating at video games. It's amazing. I'm going to be able to design this whole circuit surface mount on a couple little boards that'll fit into the little notches of the Elite Core belt loop. I like that it's called Elite Core because it gives it way more cool stuff. He's cheating at IRL. Twitch, ban him. Twitch, he's cheating at IRL. He's a monster. This is disgusting. Disgusting. Physics cares about your feelings. They just want you to feel bad. That's why quantum physics is quantum physics. I guess technically physics is your feelings if you break it down to a molecular level. All the stuff that you're feeling in that complex lump of pudding that has electricity going through it are technically slaves to the laws of physics, although the complexion of the entire, the complicated nature of it keeps us from knowing exactly what's going on. But anyway, yeah, the model that I've made for this thing using parts from Switchcraft and just Fusion 360 nonsense, we know what we're building into, but I still, I need to verify that the circuit works before I build an EQ on it. Building EQ on it is going to be fairly difficult too. It's just like, I did my best. I built it as organized and neat as I possibly could. We got all the bases and the collectors. Everything's wired up properly. I mean, I got power running to those, which I think is all that it's connected to. Holy fuck, that looks fun. Which one? You talking about that? Or are you talking about that? This? This, by the way, this is the other project that we have been... Oh god, my chat keeps reconnecting. So yeah, this right here is Burn the Subs, and this is my wall-mounted laser etching table. What burns the names of subscribers onto itself. It hooks up to the Twitch it hooks up to the Twitch API, and then it turns names into G-code instructions that it streams out to a little stepper motor setup, a little etching table setup. It's all in software. We're going to be working on that soon. Yeah, we're going to be working on that more soon. I need to finish the Y-axis. That's the one thing that kind of we tripped up on a little bit, but it's coming along. I'm doing Fusion 360 for the Y-axis because I want to 3D print stuff in the wonderful red filament that I got, and that'll attach all the lasers and stuff to the Y-axis. That goes back up on the board. I'll do some final checks and get all the belts in there and everything. I got to clean up the control board a little bit because there's like water like nonsense in there. It's like I gotta clean it out. There's like white like salt or whatever in there. Weird. I'll clean that out, do a flush of the coolant system and then put that back up on the wall. And then I would like to plug a controller into my Raspberry Pi so we can make a piece of software that will allow me to trace the edges of the live edge board. From there, I just need to kind of tweak some of the parameters of Burn the Subs so that we get the look that we're looking for. We probably need to add a couple lines of codes, because a couple lines of code, once you get rolling with Python, it's pretty cool. Like you can just, do all kinds of cool stuff in the Raspberry Pi. But the couple lines of code that I need to add will look for the gift sub parameter in the XML that comes back from Twitch for subs. So gift subs will be locked into a single line font, and subs coming from you guys directly will go into the bubble letters. I don't have a tour video. There's potential for my address to be everywhere. Oh my God, is that a tiny Thurston Waffles in the corner? So what's going on with this circuit? Yeah, it's actually the funny part about that XML return is that there's technically 2 XML returns from the Twitch API. This is how disorganized the Twitch API is, and it really fucking pisses me off. What happens is you get one XML message. Sorry, it's JSON. I'm sorry. Yeah, it's JSON, but it's sort of that. Sorry, I confused the two. It's a JSON return. We treat it kind of like XML. Sorry. The JSON return, one of the fields in the JSON return is another JSON return in text. Ugh. I tried to teach myself Python for the Raspberry Pi. All I managed to do was make a portable N64 party box. That's cool. I mean, that's cool. But like, the cool part about the Raspberry Pi is that you can do a headless Raspberry Pi, and then you can throw a text file of Python into it and run it off of that. And you can edit it. You can edit it like on the Raspberry Pi on your computer. And then you can throw a little bit of physical computing code on there. Very simply done in Python. Boopity boop boop. You know, it doesn't need to be fast because you're doing simple stuff just to learn Python, and you can just throw code at it all day and make it do stuff in the real world. It's really it's interesting doing that. I mean, personally, if I'm making like a project install or something like that, I prefer to use microcontrollers. But if I needed the complexity of like atomic clock, stuff like that, I don't know, like an online randomizer or something like that, something weird like that, you could do that very easily with the Raspberry Pi. It's kind of cool. I need to set one of those up for my remote stuff. Yeah, I was gonna do what is it? RTS LDR radio, so I could look at like flight paths and stuff around here, but I was technically able to plug that in upstairs. Ho, Krug! Hurrah! Krug. Thank you for following. But yeah, it never got really good reception. This place sucks. Yeah, software-defined radio. This is one of my Raspberry Pis is a Plex server. I should probably do that. I should set one of those up. I never set up a lot of that entertainment stuff. I'm old school. I like files and folders. I just open a file in a folder. Yeah, software-defined radios are really fun. They're really fun. All right. We do one last ride, one last buzz of the circuit. One last buzz through this circuit, and we're gonna see what I might have done, what I might have did. Because the thing is, like, we get no audio, right? We get no audio. That's so weird that we get no audio. Somebody before was like shocked that we didn't have anywhere that power was plugging in. This is phantom power. The files are in the computer. One possibility is that we got a bad Zener diode in here. So maybe we do just take out the multimeter. It's either the multimeter or the scope, and one of those is probably eventually going to happen. So let's grab the multimeter. Let's just look at the DC voltage here. DC volts. Let's take a look here. Let's see if we're even getting power into this thing. So in order to do any testing on this, I am going to have to cut off my audio. I like the way the circuit turned out, though. It's pretty organized. This is how I do stuff. I try to keep it very organized. All right, here we go. Oh, yeah, I'm going to The Zener was in backwards. You guys might be able to hear me. I don't know what my voice sounds like. It seems to be cutting off way too easily, though. It feels like the compressor is doing stuff to it way too quickly. Yeah, look at that. My gain is way down. I've got to like yell. Yeah, the sound is much lower. So I do need those 100K or smaller. Yeah, 120 versus 100. Yes, I know. Thank you guys. I appreciate it. Thank you for telling me what I already fucking know. Yeah, I'll find better resistors for it. I have to like yell in order to keep it going, in order to keep it up. All right, our test bed works. We got to change out some resistors. Let me go back to the regular one. Well, thank you, Cannibal Jesus. I appreciate that. Yeah, it's pretty finely tuned, huh? Need to switch in that? Maybe. I don't know. It's too complicated with Phantom Power. Okay. So yeah, the Zener diode was in backwards. The diode's function with a Zener diode, with a normal diode, basically when you get to a certain voltage, there's a bias in the silicon. It's 2 layers of silicon, and there's like a boundary condition with where the holes in the electrons are. And so when you bias one side, why don't you guys just type out how a fucking diode works, and I'll just leave. I'll just leave if you guys want to you just do it. It's your show now. You just do the show. Man. All right, anyway, what happens to the diode is that you have a bias, you have like a voltage, right? And there's a voltage drop across the diode when everything starts working. But if you increase the amount of volts on both sides of the silicon, the holes in the electrons, that boundary layer starts to expand and move. And when it finally reaches a certain point, then electrons will be allowed to flow through. Any amount of electrons will be allowed to flow through, which means there's no control over the amount of current going through at your voltage. There's a voltage drop across the diode because it actually has to do work. And so that can run away and the diode can heat up and explode. They explode a lot less nowadays because of the formulation of the epoxy that covers them. But, you know, diodes used to explode. It was awesome. You could put a 9-volt battery on an LED and it would pop. It would actually physically pop. A little piece of the plastic would shoot out. Unfortunately, you can't do that anymore. It doesn't outgas like that, like it used to. But anyway, the point of a diode is essentially like flow control. You can do a lot of cool stuff with diodes. You can charge capacitors. You can do all kinds of weird like timings and interactions. You can blink an LED. You can blink an LED with one. Yeah, I used to work in Giado. Well, we weren't really super associated with it. It was basically with the FBI. But anyway, so with a diode, you can limit current, you can turn AC into DC, you can do all kinds of fun stuff. And when you look at a diode, you look at a chart of the voltage versus how much current is allowed to pass through. With a Zener diode, they changed the formulation a little bit. They doped it differently. Hey, get the hell out of here. They doped it a little bit differently. And so when they dope it, doping is when you change the content of the silicon, right? So you change the content of the silicon, and that changes either the ratio of holes to electrons and blah, 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 blah. That's why it's a semiconductor, because you can dope it and you can make it do different stuff. You do N channel and P channel. So when you dope it just right, you create a Zener diode. And what happens is, in forward bias, when you have positive and negative on the right sides of the silicon layers, on the P's and the N's, then you get what is typically a normal diode. So as you increase your voltage, all of a sudden, boop, it pops off and you get a shit ton of current through there, right? But if you run it in reverse, there is an extremely hard cutoff that's consistent at a certain voltage. So when I put in the Zener diode backwards, which is technically the anode and the cathode are on the correct voltage biases for a normal diode. If it was an LED, it would have lit up. When I put it in a normal configuration, we saw a voltage of 0.7 volts. Bada bing, because it was bleeding off all of that excess current and just shorting it out at 0.7 volts, and that's all that we had available to us. When I reversed it, bada bing, suddenly we got exactly the voltage that we were looking for, plus or minus 0.05 volts. So, bada bing. So anyway, the cutoff on this diode is 9 point something something. When I put it in at first, because this is the middle line, no, the positive and negative are in the same orientation. Never mind. Well, anyway, I put the band on the wrong side. So we flipped it and then it worked. Now, because we used 120 ohm resistors on this part of the circuit, because of those 120 ohm resistors, that means that both of my outputs were not getting as much gain as they typically would. If I wanted to put a volume knob on the actual circuit, that probably would be a good place to put like a 90 ohm pot, or like a 110 ohm pot or something. Actually, no. Maybe a 300 ohm pot or something like that. So I could probably adjust it if I really wanted to, but then it would be unbalanced. So you need a dual gang pot, which are harder. It's not easy to find. Anyway, we know what we're doing now. We have a test bed. This is good progress. The next part of this is going to be building the EQ circuit, and unfortunately we didn't get to that today. We did a little bit of troubleshooting. You guys got to see my typical breadboarding. I need to pause for a significant amount of time whenever I say that, because I confused perfboard and breadboard once, and from then on I was always like, ugh. Yeah, I could do a dual gang pot. I've got 100K pots here, but that's way too much. I'd have to like find something that would work. I'm not gonna do that. I'm just gonna put like I don't know if I have 100 ohm. I'll look around for it though. They're easy to replace. Unfortunately, they are also doing kind of like a custom length thing, so they're not that easy to swap out. But I'll just have to. Well, they're not that hard. I can just pop them out. Oh no, actually, wait. Those are these. Yeah, those are really easy to pop out. Yeah, I just got to change these two little Jim Jams right here, and then this John will have all the gain that we want, and then we can pipe over to here and do all of our EQ stuff. I can put that part of the circuit together. And at that point, I'll have to put on headphones, because that means that I can sit there and tune all of my audio properly. That'll be cool. We're going to work on this again, maybe Thursday. Tuesday, I absolutely have to work on Burn the Subs, because we need that. We need progress on Burn the Subs. I've been splitting the projects in half, because I want to do the EQ, but at the same time, I also want to make sure that my, Burn the Subs comes back. No, the EQ will not be done in software. This is how I do my EQ right now, which is software. We're trying to make it a hardware thing. So we have from Elliott Sound Projects, which is a wonderful, wonderful website. Has a lot of really cool stuff in it. What we're going to do is we're going to grab the EQ from one of his projects, and we will use that to attempt to get close to this and get what sounds correct. Although I don't listen to my own audio. You guys are the ones that listen to it. I listened to it a lot when I tuned up the EQ at first. I recorded some quick videos in OBS in order to tune all the frequencies of my voice. But we'll have to do that again. We'll have to do that live on the air. And the problem is the feedback is instant, so it's kind of hard to figure out. And also the adjustments are going to be little trim pots, so it's not going to be easy to know where I've adjusted it to. Like the way that I did it originally was recording a video of me dragging these bands up and down until it sounded correct. That's how that came about. That's how I got these. So I recorded 1, 2, 3, 4, 5, 6 videos, and then I put it all together, and then I tweaked it from there. So I had to record video after video, short video, with me saying the same test phrase over and over again. If you guys are interested in getting good VST filters, start at the M Audio. There's probably other good ones, but then you have to actually do work. It's not all just installing software. You have to sit there and you have to say the same thing over and over for each of your channels. Yeah, I mean, I guess I could do like a VST that would put in delay or something like that. Maybe I could do that. I think one of the M Audio does. Yeah, not work. No, you have no idea, man. You have no idea how little work streamers do. You have no idea how lazy streamers are. You know those like tomato sound effects that he knows and loves? The little like creepy, the do-do-do-do-do-do-do-do. It's literally the default set to this button. It's just, I could plug this in and hit this button and it would make the exact same sound. Streamers are lazy. They're super fucking lazy. The ha ha ha, what the only one that he added to this was the that's the only one that he added. The rest of them are default sound banks on that Rodecaster. But I'm looking forward to actually being able to use that thing, because essentially streaming is podcasting, and that's a minimalistic interface that I would need in order to mix in things like the computer and guest stars and stuff like that. Like if I have Julian here helping, working on his synthesizer project, it would be nice if I had the EQ that I like built into that mic pack. You see, the only thing the Rodecaster doesn't do is the EQ. I'm not sure if I can get the compressor to work like this. I hope I can, but we'll have to see. But yeah, literally the only things that affect my audio are the EQ and the compressor. So if I can put the EQ in there, it means I'll be uncompressed, so I'll get very loud. But if I plug into the Rodecaster, that means it'll even it out. And then all my settings are in a piece of hardware that I can move around. Whew, man, that was a hell of a trip today. We got it working, and we know exactly why it doesn't work exactly the same. So that is furthering this project, right? Audio output, you could plug in instead of the mic to replay a recording. That would be good. That would be really good. But the mic is an Electret mic, and we're directly driving it. So it's a little bit, I think we're a little bit beyond, because we're trying to tune it to my voice. I guess it depends on the day how my voice is going to respond. But like this, I don't think I can insert a virtual Electret microphone to play the same phrase again and again. It's better that you're just there doing it. Sometimes automating the task is too much additional complexity to set up, and you just want to just sit there and do it, So yeah, we did it. We created our audio test bed. There's like sound waves coming out of. All right. Thank you guys. Thank you guys for joining me during this. Those of you who are unfamiliar, and I know people were making comments on it, those who are unfamiliar with things like breadboarding and stuff, when is the next parts scavenger hunt? Man, I don't know. I need to find a piece of hardware that I really feel like taking apart, I'm always looking for stuff, though. I'm always looking for stuff. I should look at like yard sales now that people are actually able to like be in proximity to one another. I haven't had a lot of good breadboarding projects recently, and I should definitely check it out. But yeah, all right. Why didn't the Discord thing come up when you did the command? Is Nightbot feeling okay? Well, anyway, the link is in here. So here's the end card. Bam! 3 days, 18 hours, 30 minutes, and 9 seconds since we're not doing Saturday. But yeah, everything is like disconnecting and reconnecting. I don't know what's going on. My chat's all fucked up. I will be on Cosmo Quest X on Sunday. I have absolutely no idea what we're going to talk about for that period of time. I'll let you guys know when I know the timing, because I don't think I was given a time. But they're having a hangout-a-thon, so I got to plug all this shit into Zoom. Not looking forward to Zoom. But yeah, hey, if you guys want to check it out, I'll see you there. In the meantime, I'm probably going to be working on this a little bit in the background. What are they doing? What are they doing? We're gonna raid somebody today? I was just gonna fucking like leave. I was just gonna get up and leave. Voice box is on. What's he doing? Are they all doing something? RuneScape. Fuck that. Nope. Animal Crossing. What the fuck is Inscription? What are they doing? Oh, pumpkin carve challenge. Oh, hell yeah. All right, let's do that. Yeah, pumpkin carving. That's perfect. I hope you guys liked the programming streamers yesterday. They're pretty cool. I was enjoying relating to all of the emotions that she was experiencing programming stuff on stream. That was really cool. All the ups and the downs, the laughing about why does this work. Anyway, let's rate Djibouti's show. They're doing pumpkin carving. I can't watch programming streams. Yeah, it takes a certain thing. We're gonna be doing some programming soon, though. We're gonna get to that. Anyway, guys, have fun at Djibouti's show, and I will see you guys maybe on Sunday, but also I will see you guys on Tuesday for the normal stream time. See you later. And then I gotta hit stop.